Joe Rogan Podcast. Check it out.
The Joe Rogan Experience.
Train by day, Joe Rogan Podcast by night, all day.
Dr. Osterholm, welcome back.
Thank you very much, Joe.
Very good to see you again.
Good to see you.
It's been basically 2 years from the day, and I think when you were on the podcast, for a lot of my friends, that was the first real fear that they felt about the pandemic. You scared the shit out of a lot of people.
Well, you know, my job is not to scare anyone out of their wits. It's to scare them into their wits. And to do what they can to deal with the situation. As you know, at that time, March 10th of 2020, no one wanted to believe this was going to be a pandemic. And so,
yeah, there was a lot of denial about how it was going to play out, and people were thinking that it was inflated or it was not that big of a deal. And then, like I said, when you came on the podcast, that like I got a bunch of calls from friends like going, Jesus.
Yeah, I think the understanding of where we've been, where we're at, and where we're going still, I think, isn't really completely clear.
Yeah, where we're going in particular, right? Now, as an infectious disease expert, it's very rare that you have an opportunity during your lifetime, during your career, to examine a pandemic and to be through it and examine the responses to the pandemic. You know, how, when you look back at it, what mistakes do you think were made, and what do you think was done correctly?
Well, first of all, let me just say that one of the things I think that's been missing from a lot of the response that we've had so far is an incredible sense of humility.
Humility.
Every day when I get up, the first thing I do is I look over at my nightstand and I see this crystal ball that has 5 inches of caked mud on it. And I try to scrape it off and then decide, what do I know for the rest of the day? And I think that we have had far too many answers before we really had the answers. And while we always want to use that term, quote, follow the science, I think we didn't do a good job sharing with the public and even within ourselves, what did we really know and not know? And what did we have to do to learn more? So I'd say it's humility.
Do you think that it's overwhelming? Like the reason, is there a reason why they didn't do a good job sharing the information with the public? And do you think that some of that might be just the fact that being involved in something that has such a massive footprint, something that literally overwhelmed the entire planet Earth, that there's so many variables, there's so many things to deal with, there's so many things to manage, that became part of the problem?
Well, you know, Joe, I think that if I had to look at it, there were days that I felt like I was trying to plant my petunias in a Category 5 hurricane. I mean, it was just one of those situations where there was so much going on. Look at the politicization. Look at the misinformation, disinformation. I mean, look at the debates. They often weren't really about the substantive issues of what was happening. And so we had a lot of these countercurrent issues. And the question was, what do we really know or not know about this virus? I mean, I'm sure there are people after I'm on here today that are not going to be happy at all with what I have to say, because I don't think we're done yet. And as I said a year ago right now, when the world was basically seeing the curve come down from that early January peak and the vaccines were flowing, that we were done. Everyone wanted to declare independence from COVID. And I said, no, I think the darkest days of the pandemic could still be ahead of us because of variants. These variants are really challenging. We don't know what they're going to do. They kind of like 110-mile-an-hour curveballs. And so I think that even going forward, we surely are at a better place right now. And we're going to be this for a while. But I don't know what the next variant's going to bring. And will it evade immune protection? Will it mean that the antibody, the immune response we've had so far, the vaccine protection we've had so far, what will it be like with the next variant? I don't know that. Maybe it's going to be fine. Maybe we're going to see it become a regular old flu-like illness every year, but maybe not. And I think that that's the challenge we have, is that kind of humility to say we don't know. And that's what's been a real problem, trying to help the public understand it, because we've had far too many answers when we really didn't.
There's an inclination to think that because Omicron is so much more mild than Delta, that this is where the direction of the virus is going. Is that correct?
That is the sense, but there's a couple of assumptions there that I think really deserve comment. Number one, the term "it's a milder disease" was really unfortunate in the sense that it gave everybody the sense that across the population it's a milder disease. If you actually look at what happened, let's say you had 1,000 cases of Delta, and 100 of them would show up in the hospitals, have severe illness, and die. Some of them would die. Well, then along comes Omicron, and instead of 100, only 10 people get serious illness or hospitalized. You say, this is a much milder disease. The problem was you have 20 times as many cases occur. So actually, your healthcare systems are much more overwhelmed. I mean, it wasn't just the total number of cases, it was the severe cases. And the last 12 weeks have been among the most severest weeks of the pandemic. And it's just because of the sheer number. And so I think that that's one thing. First of all, this was a mild disease for a lot of people, but for a whole lot more, it wasn't. I think number two is the fact that, we don't know what these variants are going to do. They could be milder again. But, we're in a very amazing place right now with a virus where when you look at its original source, from a human to another human early on in Wuhan, but, it had to come from an animal at some point. Well, now we're seeing all kinds of animal species infected with this virus. Look at what's doing with white-tailed deer. I mean, in my 46 years in the business, I've never seen data like I've watched the emergence of this new variant in wild deer.
Yeah, it's very strange, right? I mean, in some places as much as 50% of the deer have antibodies.
Yeah, well, in fact, even if you look at studies like in Iowa, where they followed it and actually looked at roadkill deer, so that it was really random across the state, they actually found, looking for the actual virus, which was a Delta-like virus, that it actually paralleled the exact experience in humans. So as the numbers in humans went way up, the number in deer went way up. Where are they getting it?
Yeah, that's the question, right? Are they getting it from the captive cervid industry?
Well, I don't think it's there. I think it's something, because it's a statewide. Even where you don't have captive cervids, they were seeing the same increase and decrease in cases. So I think what it's really pointing out, though, is that if you look at all the other animal species that get infected, and then you look at the potential for humans to continue to get infected, I don't know what the next variant's going to bring, and no one can tell you that. And if they do, be careful, because they probably have a bridge to sell you.
Yeah.
So you could have one, it gets milder, and we surely have 4 coronaviruses right now that typically cause milder disease, cold-like symptoms. Maybe it'll go that way. On the other hand, it may reassort, meaning that it swaps out its genetic material like a flu virus does with other coronaviruses, and we could see a new punch. It could actually evade immune protection. We don't know that. So I think the challenge we have is just being honest with everybody. This is the guardrail. One side is it could go back to another Omicron-like experience, or that may be the last one. I hope for the last one being the mild one, but hope's not a strategy. So you got to look at what do we need to do to be prepared. And right now, everybody in this country wants to back away, back off, and say we're done, which I want to too. I feel that. But at the same time, I have to say, I don't know that we're done. Just like I said a year ago, I thought the darkest days were still ahead of us.
Now, when you say that, so Omicron is far more contagious than Delta and far, far more contagious than the original variant.
Yes.
Right. Now, when you say that maybe, whatever numbers that you used, that it's less likely to cause hospitalization, but because it's infecting so many people, you actually get more hospitalizations.
That's exactly right.
So what's the cause? Like, why are some people getting badly hit by it, whereas other people, it's just a runny nose?
Well, and we don't know. We do know a couple of things about protection. Number one is if you've been vaccinated, particularly if you've had the third dose, if you've previously been infected, which also does add to your immunity, clearly, those obviously work in your favor. If you have some of these underlying health issues that we've talked about, which, it's not just about being in shape or not. People with diabetes, people with asthma, people who are immunosuppressed. There are 7.5 million Americans right now that are immunosuppressed, either because of the disease they have, they're being treated for cancer. All those people are at much higher risk of having severe illness. And even what we saw with kids, we had never seen this level of activity as we see with Omicron with kids. And so I think the challenge we have today is...
For hospitalizations?
Yes, even for hospitalizations.
Now, the kids that were hospitalized, did all of them have comorbidities?
No, many of them did not.
So some of them were not even obese?
Yep.
And they were hospitalized?
Yes, absolutely.
Really?
Yep. Omicron clearly really took a hit on kids.
That's interesting because in my kids' school, a few kids got Omicron, and it was essentially like me or my friends who got it. It was very mild.
If you look at it right now, just through this up till this past month, with most of this activity having been primarily in the last 6 weeks, 1,334 kids between the ages of 0 and 17 have died from COVID.
1,334 kids.
Yep.
And out of these kids, how many had comorbidities? How many were obese?
Some did, but a comorbidity is
Just
not just
some?
obesity. Yes.
Right.
In fact, let me come back and say somebody who has diabetes is considered having a comorbidity.
Sure.
If you look at somebody who has asthma, which about 7% of all the asthma in the country is in kids.
All sorts of autoimmune diseases.
Exactly. So
Yeah.
all of those add to it.
Right.
And so that's been part of the real challenge we've had with this.
But for normal, healthy kids, is this something that's more dangerous than Delta?
Absolutely, it was.
Really?
Absolutely, it was.
Is that shocking to you? Because it seems like for adults, the effect that it has on the general population, it seems that the consensus is that it's more mild.
Yeah, I think that's one of the challenges we have. If you've known the COVID-19 pandemic in 2020 and you knew it in 2021, doesn't mean how well you know it today, because things have changed.
Right.
For example, if you look at the infectiousness in kids, the early data we had on how well this virus transmits in kids was before we ever had the Alpha variant, which showed up in roughly December of 2020 into January 2021. And we found limited transmission in kids, limited severe illness. Then Alpha came along, and we saw much more transmission. We had places in this country that had large outbreaks, school-based outbreaks. Then that kind of went away. Then Delta came and added even more transmission with kids than we'd seen before, and Omicron was the king. And so I think if you knew COVID-19 back in 2020, you didn't necessarily know it today in terms of the infectiousness and what we saw happen. So I think that's one of the challenges we have, is just keeping up to date on what it did and how it did it with kids.
And the variants, as they so there was the original version, and the alpha version is the first variant that was discovered.
Well, that's what they've labeled them by is the Greek alphabet. So alpha was kind of the first one there, and then we've had subsequent.
But not the original virus, but the first variant of the virus.
Yeah. Well, what's really interesting with this virus is the fact that if you look at what we call the ancestral variant, the one that originated in Wuhan, all the subsequent variants we've seen have actually all gone back, and their roots are in that ancestral variant. It doesn't mean that if you had Alpha, it turns into Delta. With a little bit more changes, it turns into Omicron. Every one of them have a distinct line back to the original variant. And that's one of the challenges we have, because that's going to continue to happen, where we're going to continue to see these new variants show up.
And as far as the variants that are in play right now, like what percentage of the infections right now are Omicron? What percentage are Delta?
Yeah.
Is there any of the original variant left?
The original variant surely is out there, because we keep seeing these new variants come from it. So it has to be somewhere. I can't tell you where it's at.
The
But
variants don't come from like Delta creating a new variant, so
It's actually take you back to the original variant. So the question on Omicron is an interesting one. Right now in the United States, virtually 100% of the variants we see are Omicron. They've
100%?
100% in the U.S. and virtually around the world. It's beaten out Delta completely. If you look in the United States, there are 3 sublineages of that variant, what we call BA1, BA2, and BA3. And we're watching a battle go on right now between those subvariants, and it turned out BA1 was the original one. We first saw kind of the original Omicron. But BA2, which appears to be more infectious now, is beating out Omicron. In some countries in the world, it's become the dominant variant. In the United States, it's still a small percentage, but it's growing. Last week it was 4%. The previous week it was 1%. So we don't know what that's going to mean in terms of seeing more of the BA2 variant emerge.
How do they make the distinction between Omicron, Delta, Omicron, and then BA1, BA2? Why do they decide that this isn't another variant? Why do they just keep calling it Omicron?
Yeah. And this is one of those questions where I'm not the world's expert on the overall genetics of this virus, but I'll tell you that the mutations that occur surely can accumulate. If you look right now, for example, there's more difference genetically between BA1 and BA2 than there is between the ancestral virus and Alpha.
Really?
Yes. So it has to do pretty much how it evolved out of that ancestral virus tree, and is it different enough? And so, there's been discussion that there may actually be some effort made to consider BA2 as a new variant of concern by itself. So, but this is, I think, the message here is this is what we have to continue to be mindful of. I know everybody wants me to say today we're done, and I hope we're done. But as I said just a moment ago, hope's not a strategy.
Right.
I think that we could still see the emergence of new variants that could challenge the immunity that we have already, which is what makes this virus so difficult and so different than what we've had before. When you see influenza, pandemic influenza occurs because a bird virus finally evolves out of the bird, gets into particularly a pig, because a pig has lungs that has receptor cells for both human viruses and bird viruses. And when they get into a pig cell in particular, they combine, they mix up. The flu viruses are very promiscuous, and they come up with this brand new strain that causes the next pandemic. Well, when that spillover occurs into humans, that's kind of the seminal event. The rest of it emerges pretty much in humans. We don't necessarily see us giving it back to the animals. They give it back to us. We give it to the animals. They give it back to us. With looking at SARS-CoV-2 and this particular coronavirus, we don't know what it's going to do. Is it going to go back and forth between animals? I mean, I could line list an entire set of all the animals that are now infected with this virus, and we don't know what that means.
The first ones that we found that transmit from humans to animals, or back to in terms of SARS-CoV-2, was it ferrets? Like, what was the first animal that they discovered that humans can infect, and they can infect us with this?
Well, there was game animals, mink and so forth in
Minks.
Europe that we saw that. But it became clear because we started seeing zoo animals infected.
Right.
Just this past week, we've heard about lowland
Cats
gorillas.
and stuff,
Cats.
yeah.
We've seen dogs and cats in people's homes where there were cases. And they got the white-tailed deer. I think there's a whole number of animal species where ultimately they could be infected with this virus. And the trillion-dollar question we don't know, will that in any way, shape, or form contribute to a spillback moment into humans with a new virus that, again, will challenge our immune systems, challenge our protection, and what does that mean? And we just don't know.
Is that the term they use, or animal reservoir?
Yes, absolutely. That's it.
So that's any other animal that can catch it. Now,
catch it and keep it going inside them. So sometimes an animal may get an infection from us and it's terminal. It ends. It doesn't keep going in the animal population. But as we just talked about the white-tailed deer, clearly there the virus is ongoing with transmission in the deer population itself.
Are there any examples of an animal being infected and then, like from a human, like a human giving it to their cat, for instance, and then the cat giving it to another human?
It's unclear. And when I say unclear, there was surely some data looking at the game farms where it was thought that some of the transmission was from human to animal, animal back to human.
When you say game farms, are you talking about like captive COVID?
In this case,
rather?
In this case, what we're talking about are primarily fur-bearing animals for pelts.
Okay.
The mink, ferrets, that type of animal species.
So that's where they first started to see the transmission?
It's suspected. It's never been confirmed, but it's been suspected there. There's been some discussion and follow-up on people's homes where somebody got infected, the animal was infected, the dog or the cat, and then somebody else got infected in the home. Well, it could just easily have been person to person, and the animal was incidental. So I don't think we have any good examples of a human to an animal and an animal back to a human. There was a recent outbreak in Hong Kong. It's now emerged into a large outbreak where they thought that hamsters were potentially being sold in pet stores were involved with being infected and transmitting. But I think the data still are out on, did the hamsters really transmit back to people? They were definitely infected, but I don't know if they transmitted back to people.
Now, this virus, are there parallels to other viruses that we could look to and see this kind of similar pattern emerging, like particularly with like transmitting it into these other animals and then the potential of these animals transmitting it to the people? It seems like there's so many different species that have it.
Yeah. We really don't have one like this, particularly that can cause such widespread disease. I mean, when you think about Omicron, for example, when this first emerged in November, I coined the term a viral blizzard because to me, that's what it looked like it was going to be. It was just going to flood the world. If you look at Alpha and Delta and all these others, it took weeks, in some cases months, before it spread around the world. This one spread around the world literally overnight. And, we're now seeing major activity in the Western Pacific region, in Hong Kong, likely in China. We're not hearing enough about it, Korea, etc. But most of the rest of the world's already been hit hard and over it. Well, that is like a blizzard, what it did. We've not seen that with any other animal-related virus in humans. Even influenza hasn't done what Omicron's done in that way.
Now, in the beginning of the pandemic, you were of the opinion that this was from a natural spillover, from the origin of SARS-CoV-2 was most likely from an animal that it spilled over into human beings. Do you still have that opinion?
Well, again, let me clarify what I said and have maintained all along, because I too have concerns about the potential for what we call gain of function or clearly biosecurity of laboratories leaking out of labs. I have not seen any evidence at all that would support that, number one, this was a man-made virus. Absolutely none. Zero.
No evidence that would support that it is a man-made virus?
None whatsoever. And I, again, with my limited expertise in viral genetics, I believe the people who I work with. Now, the question is, could it, however, been in that lab and spilled out because somebody got infected, there was a lab accident, which surely can happen. And again, we don't have any conclusive evidence that happened. I think even anecdotal evidence we've had has been very short. But I'm the first one to say I wish we'd had a much more exhaustive investigation into what happened at that laboratory, with much more transparency. I don't think we've had that kind of a transparent investigation yet. To see, were there sick people at that time? Because if it was going to spread out into the population, there would be sick people. On the other hand, I'm not surprised that it might have emerged in Wuhan, because here's an area of over 40 million people living in that whole area, for which their food sources come from hundreds to up to 1,000 miles away, of which the open markets there are ripe with the kind of animals that very well could have brought the virus there. And when you look now at the ease at which this virus goes between animals and humans, at least initially, or humans or back to animals, it's not surprising that it might have emerged there. And so I am still open to the fact that, was it a laboratory accident? I don't have any reason to believe it was an intentional one. I know it was based on everything we have. It was man-made.
But I don't think anybody thinks it's an intentional release, do they?
No, well, some people have. No, some people think...
Well, I shouldn't say anybody, because some people believe the world's flat. Right?
That's absolutely true, too. That's absolutely true, too. So I think, but I think that it is fair to say that there still remains this question, could have it leaked out of that lab? And I continue to say I wish we would have an exhaustive, comprehensive investigation, which the Chinese government would agree to.
Is that part of the problem, a lack of transparency?
I think it is, but let me paint a picture here that also helps explain the situation. Imagine a brand new virus emerged in the Caribbean. Okay, I mean, it came from nowhere. It might be a mosquito-borne something. Okay, where do you think they might find that virus first? Atlanta. Why Atlanta? Because it's it's the transportation hub for the Caribbean. And they have the sophisticated laboratories there, not even at the CDC. I'm just talking about universities, et cetera, clinicals. Imagine if that virus was found in Atlanta, a brand new virus. The assumption we made immediately, it came from the CDC. Because it's there. It's geographically there. It's in Atlanta. That has to be the source.
I see what you're saying.
And so if that were the case, imagine the Russians and the Chinese saying, wait a minute, this was a lab leak out of CDC. We want to come and investigate. We're going to come in and see. Mm-hmm. Do you think the U.S. would just willy-nilly open up the lab at the CDC to the Russians and the Chinese?
Right.
So in some ways, I'm not being sympathetic at all to the Chinese, because I think they are continuing to make the problem worse by not providing more transparency. But at the same time, if the same thing happened in the United States, I could see where we wouldn't just open up the CDC to everybody in the world to say, okay, come on in and look.
Right, but is the CDC doing gain-of-function research on coronaviruses?
They're not.
They're not. Well, so if something emerged from there that wasn't something they were working on, that would probably not arouse the suspicion of the world. I think part of the problem with what's going on in Wuhan was that lab is a level 4 lab that was working on bat-borne coronaviruses.
Exactly. No, you're absolutely right about that. But at the same time, CDC might be working on a lot of the viruses that would emerge in the Caribbean. And they would have labs that were working in that because some of their best expertise is on, for example, mosquito-borne viruses in there. So I'm merely pointing out that it's not just the fact that the Chinese have basically stonewalled us. They have. And unfortunately, I think that can be interpreted as, there's definitely guilt there.
Right.
I think some of it has to do with this issue where they just opened their lab up. I just wish they would. And let an independent group from around the world go in, examine all the records. Was there any evidence of illness around that time? Was there any unusual activity? The viruses they have, what they've self-reported, were not any that were close to this one in terms of actually, that actual virus was in the lab that was suddenly found in Wuhan. So I think continues to be a major distraction.
Wasn't there recently a version of the virus that was discovered, a very early version of COVID-19 in one of the labs?
There's been a number of SARS-CoV-2-like viruses there, but again, this is out of my area of expertise, but the viral geneticists I know would say there surely is not the direct link yet that virus came from that virus in the lab. And so I think that, but that's the kind of thing we need to have the transparency on, and I wish we'd move on. I wish we'd move on then.
So the part of the issue is that there's just not enough data from them to make an accurate, honest, clear determination.
That's what I see. And I do see a virus that right now sure is very effective at moving between people to animals.
Right.
So it doesn't surprise me that it could move from animals to humans.
Now, the people that are suspicious that this did come from some gain-of-function research, they point to that as an indicator that this is a virus that was at least cultivated in a laboratory, right?
Yeah, and I see no evidence of that. And let me just come back and add a context to this.
Okay.
I sat for a number of years on what was the newly established basic group inside of the federal government to look at biosafety and biosecurity work, the National Science group that did that. And, for all the years from 2005 to 2012 that I was on that, I was one of the really outspoken people about my concern about doing influenza work in labs where they were trying to understand virus H5N1, a bird virus that occasionally infects humans, but could it one day become the next pandemic virus? And a group of researchers wanted to try to gin up that virus by passing it multiple times in ferrets and looking to see, can we predict when it might become readily transmissible between mammals, i.e. could it infect humans? And my concern was all along, wait a minute, what happens if this gets out? What's the challenge? You could start the next flu pandemic. So I have always considered myself kind of the champion in a way, amongst others, of looking at biosecurity as a really critical issue. So I come into this with the Wuhan experience feeling the same way. I think this is an important issue. I think it needs further discussion. But again, I don't see any evidence at this point that anyone has provided that shares that this is what happened. But I think we just need that transparency we don't have yet.
So there's not enough evidence to draw a clear conclusion, in your opinion?
None. And
now, there is some anecdotal evidence, right? There was I believe there was 3 researchers at the Wuhan lab who did get ill with a very similar disease to COVID-19, and one of their spouses wound up dying, and there was some indication that could have been the initial source.
Yeah, let me first of all just say, in my world, anecdotal evidence is not really evidence. You know, it's not storytelling, but I see so many of these things. Yeah, and I've never seen any of those data corroborated by any responsible group. It's kind of one-off. It's kind of that old idea. President Kennedy's secretary was named Lincoln. President Lincoln's secretary was named Kennedy. So there must be a tie between the 2 assassinations. It's that kind of thing.
Yeah.
I've seen nothing that supports that activity at all.
So as a scientist, you're just not willing to make that leap.
I'm not willing to make the leap, but I'm willing to make the leap if we get the evidence that it's there. So I'm not sitting here saying write it off.
Right. I get it.
Yeah.
In the early days, there was some evidence that was deleted. There was a lot of files that were deleted from the Wuhan lab, and that a lot of people pointed to that as being an indicator that they were not just not being transparent, but withholding some data.
Yeah, at this point, I can't comment on that to say I know exactly what happened. There surely was some evidence that there had been some files moved or deleted. Also, there's been evidence that some of those files have been replaced, etc. So I can't comment beyond that. But again, the people that I most respect in this business who have concerns like I have not pointed to that as being any evidence necessarily that that's what happened, was that there was data that they wanted to get rid of so people wouldn't see it.
Right. It's just, again, not enough, right? Is that what you're saying?
Yeah. In fact, I wouldn't even say not enough. I would say I'm still waiting for even a limited smoking gun to come forward and say that. I just haven't seen anything like that. I'm open to it. I'm willing to it. I've said time and time again, I wish that their Chinese would allow for an exhaustive outside review of what happened there to corroborate all these pieces of information or basically show that they're not true. And I think that would put us all in a better place of trying to move forward.
Is there proof that they deleted evidence?
I don't have any proof of that. I don't know.
You don't know?
I don't know.
If there was proof that a lot of files were deleted, would that give you pause?
Well, I'd want to know why.
Right.
You know, we delete files all the time on research things after things are completed.
Mm-hmm.
Now, on the other hand, laboratories typically keep everything forever because they may have to go back to it at
Right.
a later date. So, you know, I can't comment on that other than to say that should be pieces of evidence or pieces of investigation that would address that.
Now, one of the things I think that you said early on in the pandemic was you didn't think that it would that it had emerged from a lab. You thought it was a natural spillover, just simply because of the design of the virus itself. That we wouldn't design something like that.
Yeah, and I still say that's the case. I mean, this thing is so effective at infecting humans, and it only got better over time. Think what it did in Mother Nature since the first Omicron, or since the first variant occurred up to Omicron. And you can see it just got better and better at infecting humans without any hand of a man-made event. And so this thing was an evolving virus right from the start that was basically capable of infecting humans and got better at infecting humans as time went on.
So the accusations or the people that think that it was made in a lab, how do they think that something like that would be created, and why do you think that that's not the case?
Well, again, this is out of my sphere of expertise. I
Okay.
am not the person who can tell you from a genetic standpoint how to manipulate this virus and what to do it. As an epidemiologist, I can tell you, I've seen these other spillover events. I've been very involved with investigating SARS back in 2003 when it first emerged in China, spread around the world. I've been very involved with the work with MERS, the Middle Eastern Respiratory Syndrome, another coronavirus. And in each one of those, you can show clearly the spillover event from animals to humans. In fact, with the camels being the main reservoir for MERS in the Arabian Peninsula, we keep having MERS cases because nobody's going to put down all these camels. We're not going to get rid of them. And so we watch those spillovers occur from time to time into humans. So coronaviruses emerging out of an animal reservoir in of themselves are not unusual. It's not somehow like A plus B plus C plus miracle ended up with the answer. So I haven't seen anything that would tell me that that was any different than that. But again, I'm wide open to whatever new data can come forward, and I hope we do exhaustively look at this.
Now, when they perform gain-of-function research, can you explain how that's done? They're using different coronaviruses and various viruses and infecting human respiratory tissue, and they're also doing experiments on ferrets because they have very similar ACE2 receptors to human beings, right? Is that the case?
I can't comment on what research they're doing. I don't know.
You don't know?
I don't know that.
But you do know how gain of function is done, right?
Well, gain of function, first of all, means that you're adding something to the virus. Like I talked about with influenza, was a gain of function where you're trying to see if you could make it transmissible between, in this case, an animal species and a human. Or you're trying to make it so that it is actually more infectious. Or you're trying to make it so that it kills, it does more damage. And those are all considered parts of gain of function. In other words, trying to make it do something else. So in terms of the coronaviruses, I've not seen any evidence of, again, gain of function because this virus is pretty damn functional on its own. It's doing very well. And it's teaching us, by just watching it, how it's changing to become almost a sense of a gain of function of Mother Nature.
Right, but the way that these experiments are done are when they're infecting human respiratory tissue, when they're infecting ferrets, and they're doing it purposefully for these experiments, aren't they allowing selection and evolution to do the work for them? I mean, I don't necessarily think they're manipulating the virus. Aren't they allowing the virus to go through its normal processes, but they're doing it purposely, right? Is that the case?
Yeah. In the principle, what you laid out, that's the case. What I'm saying is I don't know that they're doing that. I have not seen any evidence. It could exist. I just don't know. I'm not trying not to answer. Doing any of those studies where they're trying to make it more transmissible or that they did do that, I just don't know.
I thought that was the entire argument that even the NIH had laid out that they had done.
Well, that had come up, and as you know, Eco Alliance, the group that was doing the work,
Eco Health Alliance?
Yeah, Eco Health Alliance.
Peter
Actually, disagreed with that, so that's not what was being done. Again,
they said they disagreed with it.
Yeah, and so I can't comment. I don't know.
Right, because this was like the arguments between Rand Paul and Dr. Fauci, and get very contentious about the definition of gain of function.
Right.
Do you think it's just splitting hairs, or do you think this is...
Well, I think anytime you consider gain of function for any virus, it's an important issue because of the potential for it to do more harm, particularly if it's accidentally released, which can happen. Again, I don't have any firsthand or secondhand knowledge that was what was being done in Wuhan.
But if they were doing gain of function, that's how they would do it. They would infect human respiratory tissue, and they would infect various animals, and they would study how this virus progresses and how it evolves and selects. Is that the case?
Well, that's one way to do gain of function, but because I'm not a coronavirus virologist, I can't tell you if that's what they're doing with this or not, or if they have done that. I just don't know.
Right. And do you know if someone or if a laboratory had done something like that and they had gone through these steps to use evolution in terms of like infecting this human respiratory tissue, infecting ferrets who have the similar ACE2 receptors, that this would somehow or another make a virus more transmissible to people?
Yeah.
That's the idea behind it?
And again, I just come back to the fact that you don't need to set up a research study today to do gain of function with this virus. Watch it in people. Watch what it's doing on its own.
Right, but that's once it's been released, correct?
That's once it's been released.
But if we're looking at the origins of it, I mean, this is what's concerning to people, right?
Yeah.
They're wondering, like, was this avoidable? Like, is like during the Obama administration, didn't Obama put the kibosh on gain of function research?
It was limited in the sense that it was for all gain of function research of how you actually were going to go about doing it and showing the safety steps you had in place to make sure that it couldn't be a release. A good example is we do want to know if flu viruses leave a mark that says we're about to become a human-to-human transmitted virus so we can plan for that. So we do want to do some of this, but we want to do it safely. And what I'm suggesting here is I don't know what happened in this lab or how it did it. I'd love to see that transparent information come out. I just can't comment.
Is it safe to say that that this kind of research is important to understand how these viruses evolve, how they become more virulent, how they can infect people and jump species, that it has to be done safely, but there's benefit?
There surely can be benefit, and there's risk. And this is all about the risk-benefit equation. And I think that's what the whole purpose of what the NIH evaluation was, of when can we declare that there's a benefit here, and this is the risk, and we can actually address the risk, and therefore the benefit is worth doing. And, you can't unring a bell. So I'm one of those people that am very concerned. I don't want to find out later. I wish we had taken more caution.
Right.
Okay. My problem is for this discussion, I just can't comment on what happened in Wuhan because I don't know.
Right, of course. Well, you're a scientist, and you look at the evidence. You look at it, and there's just not enough of it, right? Is that safe to say?
Yeah, and I'm open to any new information, as I said before, that comes forward.
Did you read any of those emails where there was discussions that were about the narrative of whether or not it had come from a lab leak and deterring that narrative? Did you read any of that?
I didn't. I didn't really, if something substantive have come out, I already spend way too many hours a day working on COVID.
Right.
The last thing I have time for is basically getting into these
politics.
It's and as you know, I mean it's oftentimes the kind of almost entertainment debate about, wait, he did this, he did that, who did this, what did that, and trying to trace it all back. And so for me, if there's substantive information, I want to read it. I want to know about it. If I can't understand it, I want to ask people who do know, because there's a lot of the parts of this, as I said, with humility, I don't understand. As an epidemiologist, I think I have a pretty good handle on what the virus is doing in terms of how it acts in people. But this particular area really does require a really level of scientific excellence in this area, for which we have people who have continued to pursue this. And so we'll go for it, and I would like to see what they come up with.
So as an epidemiologist, you are just trying to follow the facts of the disease and avoid the weeds.
Exactly.
Okay.
And be really clear about this, is that I think that we have to have these discussions, but how we have them, they have to be based on data. What we can't do is more, it's like the Kennedy-Lincoln analogy I just used, and now it proves a point, so therefore now the assumption is, well, they are linked. I can tell you, the CIA of the 1860s were still active back then, and they're still active in the Kennedy era. That does not help. And to me, that's where a lot of people find they spend time. I don't.
I don't know if that's a good analogy. I see what you're saying, but we actually have the actual people that were trying to say that it seems like this is coming from a lab, and these were credible people from legitimate universities. And then you had some other people that were trying to say we need to disparage these people and we need to look at them as if they're fringe conspiracy theorists.
Yeah, I think in the early days that happened in a way that...
Why would that happen?
I can't comment. I wasn't part of that discussion. I did not get involved with that discussion because I felt like it was,
right.
It was in the weeds in a way that, I was trying to figure out what this virus is going to do to kill people and how I could stop it from happening. So to me, again, I will let the experts who have that kind of expertise deal with it. And rather than he said, she said, I stay out of it.
Got it.
That's why when I tell you what I know, you better count on it's true.
When
I tell you that I don't know something, then you can take that to the bank too and say he just didn't know.
I appreciate that. What about one of the weird things of this virus in the early days was how many people were asymptomatic, and and it didn't matter by age. It seemed like there was quite a few older people that were asymptomatic that got it. And do you think what do you think the reason for that is?
I don't know. And I can tell you right now, that is a point of discussion I've had oftentimes with my colleagues. We do know that it's not likely tied to dose. Originally, I was a co-author.
You mean
on a
by
paper.
viral load?
Yeah, by viral load. How much virus is there didn't dictate how seriously ill you did. It didn't mean you didn't get infected or not. And we're still looking at that. What it does indicate is clearly having these comorbidities adds to the likelihood that once you get infected, you're going to have severe illness.
Right.
But as you just pointed out, and is absolutely true, we've seen people who have comorbidities who've had mild disease. We've had people for unexplained reasons, we don't know why, have had serious disease, younger, healthy, underlying comorbidities, physically fit. And so generally speaking, though, you can say that no, in fact, if you have these comorbidities, you are much more likely to have severe illness, but it's not totally the rule. There are those exceptions we see. And as I just mentioned, these kids, a number of these kids did have comorbidities, but some didn't. And why they got infected and died, I don't know.
Is there a parallel to any other disease that you've ever studied before or that scientists have studied? Like, is there any disease that behaves this way?
Well, clearly there are a number of viruses where the seriousness of the illness can vary a great deal by age, for example. Let me just take one that is not a respiratory transmitted agent, but the virus that causes hepatitis A or infectious hepatitis. In young kids, this is often a very mild, totally asymptomatic infection, and it's transmitted from fecal oral. If you have diaper changing, et cetera, it's not, hygiene's not there. We would often pick up outbreaks of hepatitis A because parents would come down with it, and they'd get really sick. Their livers would be in trouble. They'd get very yellow and jaundiced. And we go back and test the child, and sure enough, the child had been infected already and brought it home to mom and dad. And so in a disease like that, the percentage of people who have serious illness, who get infected and have illness in general, is much higher than the older population than it is in the younger population, where it's almost a mild disease. So we have examples like that do happen. It's not as if it's an unusual situation. And for some diseases, the vast majority of illnesses are mild, asymptomatic. You only pick them up by doing blood studies in populations. For other diseases, well, rabies is, of course, the classic example. It's virtually 100% fatal. And so it varies across all the viruses we have.
So is the percentage unusual of people that are asymptomatic with this disease?
Well, I think, Joe, that's one of those questions, again, that kind of begs the very issue of what is this SARS-CoV-2 virus all about? Because if you go from the beginning of the COVID pandemic to now, look at how different the ancestral variant illness was to Alpha, to Delta, to Omicron. It's just in a matter of 2 years.
Right.
I mean, it's amazing how much. And the question you asked me earlier about the issue with Omicron, why do we see so many infections out there? Well, because it's much more infectious. And I think that what we're watching here is a really real-time evolution of a virus that, we could never, suggest for a moment that the measles virus is going to change a whole lot in 2 years. It hasn't changed basically in decades and decades and decades. So I think this is one of the challenges we have and when I answered your question earlier about what is the future of this pandemic, it's because this virus keeps throwing 210-mile-an-hour curveballs at us. I don't know what the future is going to bring yet. Maybe one of these variants is going to spin out of this that is going to, again, cause a large number of cases, some of it severe, and is going to evade the immune protection that we have already.
I've read some articles that seem to indicate that there may be some immunity that certain people have because of previous infection for other coronaviruses, meaning common coronaviruses,
Yep.
that somehow or another that may have imparted at least some kind of either immunity or some kind of protection from SARS-CoV-2.
And that is currently being studied. And in fact, if you look at the issue of just take immunity from SARS-CoV-2, if you look at the data for Delta, you could actually show that basically those people who had previous infection did better than those who hadn't had previous infection and were vaccinated. I mean, actually, they had more protection. But if you go back to Alpha, people who had previously been infected were more likely to get reinfected than people who were vaccinated.
So people who caught the Alpha variant could catch it again?
Yes, well, everybody. Look at Delta. Delta the same way. People
caught Delta more than once?
Oh, but it's not. I'm sorry. I'm talking about when they actually have the next variant. So people who had Alpha did get Delta. People who've had Delta got Omicron. And it's really too early for us to say what happens with BA1, BA2. Can you get Omicron a second time? We don't know yet. But so when I was talking about for the Alpha issue, we were talking about people who had previously been infected with the ancestral variant. Now actually with Alpha, we're basically more likely to be protected by vaccine than previous infection. For Delta, if you had Delta, basically you were less likely to be protected from vaccine and more so from previous infection. And so what it's pointing out is this is a fluid situation, and we're still trying to learn with Omicron. We had a lot of breakthrough infections with Omicron. What was it that protected you or didn't protect you with Omicron? And we're still really looking at that issue.
And that is with people that have been previously infected as well as people who have been vaccinated with Omicron, correct?
Right. So if you look at just hospitalization alone, if you were unvaccinated, you had about a 79.6 per 100,000 people were hospitalized. If you were fully vaccinated, it was only 4.4%. Okay?
So 79 people out of 100,000 were hospitalized
if you're unvaccinated. And it was 4.4 if you were, in fact, previously vaccinated.
4 people? 4.4 people versus 79 people?
Yep, right.
So a lot of people thought it was a lot higher than that. Like there was an impression that when you got infected by SARS-CoV-2, that there was whichever variant, that you had a high likelihood of being hospitalized.
Yeah, and this is for Omicron. Remember, we just talked about the fact that for many people who were infected, you didn't even get seriously ill.
Right.
But for those that did, yeah, they were seriously ill and the number of deaths were elevated.
Do you think that there was a wasted opportunity to discuss metabolic health in terms of weight loss, in terms of taking care of yourself and eating correctly and vitamin supplementation and exercise? All these things were kind of ignored during the pandemic.
Well, I don't know if I agree with that because, I surely have heard it over and over again that this was important. But it's important for everyday life. Basically, whether you have Omicron or Delta or SARS-CoV-2 at all, these are important things that you should be considering. Okay.
Do you think that was reinforced by the government?
Oh, I think particularly around body mass index a lot.
Really?
Oh, yes, I think so. But I gave many talks where I was talking about...
You might have given many talks, but this is not something that was echoed by the White House where they were talking about it openly in public. Hey, folks, you got to lose weight.
Well, I think that if you look at just even the recent weeks in terms of the discussions about comorbidities and what they are, you have to separate out those ones which you can control, such as you said, the exercise, that type of thing. Those which are unfortunately just a part of your health profile, diabetes, asthma, autoimmune diseases, etc. So, I fully support the fact that we should be emphasizing this issue around body mass index, meaning i.e. should lose weight, etc. Yeah. And I agree with that.
It's really obesity. But body mass index is a weird one because I'm technically obese by the body mass index.
Yeah, and in that sense, you're right. You're right. It's really about weight. And
the weird thing about COVID-19 also is the way it attacks fat cells, correct?
It can, and that can be part of the amplification of this immune response issue that we work on. Yes, absolutely.
Is that really unusual? Or how much of a factor is obesity in terms of just a general immune system robustity?
Well, I can't say... Again, I'm not the expert in metabolic disease issues, but we know for a number of conditions that if you have increased weight, i.e. body mass index-like measures, that you are at a higher risk of having the additional problems because there is, from an immunologic standpoint, some activity with fat cells that can surely enhance an overvigorous immune response. And remember with SARS-CoV-2, it's a combination of directly what the virus does to impact you, but also what does your immune system do? One of the examples we're all very concerned about today is long COVID. And with long COVID, it's clear that that is not evidence. It is not evidence at this point of an ongoing infection. It's not that the virus is still proliferating in you. We just haven't gotten rid of it.
So can you explain what long COVID is technically?
I can't. And the reasons I can't, it's not because I'm not even an expert, because most people can't. It's a whole series of different conditions, the brain fog, the fatigue, the cardiac involvement, the heart, as we see the heart, the lungs. And it's not really clear what is going on. If you just take a step back, remember before COVID ever existed, we had chronic fatigue syndrome, a real condition, and people were really suffering.
And when you say chronic fatigue syndrome, is that something you can have a test for?
No, that's the whole point, is that it was kind of a general term, a catch-all, that basically covered people, and most often it was associated with people who had had an infectious disease of some kind, which may have triggered this ongoing immune response.
Is there a specific infectious disease?
Well, Epstein-Barr virus has been often implicated as being a part of this picture. But what it's really pointing out is it's really about this ongoing immune response that we don't yet understand. And I think if there is any area right now that we need tremendous efforts put into, it's long COVID. There are these new centers starting right now to try to address this. Overall, we estimate that there may be anywhere from 3 to 10%, some say as high as 18 to 20% of people, without regard to whether it was serious COVID they had or milder COVID, go on and develop this long COVID.
There's an interesting parallel with fighting. I can talk to you about this with MMA fighters.
Yeah.
That some MMA fighters who have had COVID, particularly ones that didn't. I don't know. I don't want to speak that they. I don't want to say that they didn't take it seriously. Maybe they didn't recognize that they needed to rest more and allow themselves to recover, and they trained through it. And guys that trained through COVID-19 tended to suffer long-term consequences from it. There's several examples of this. And after those bouts of COVID-19, there's a thing that happens with fighters at the very highest level. And one of the things that I study with the UFC is I'm studying like the elite of the elite athletes, like championship level fighters. And just a small drop off of performance is noticeable when they face other elite athletes. And you're starting to see some of these folks that have had COVID-19 then competing and not looking as good 8 months later, a year later, post-infection. And I'm wondering, like, what is this long COVID? Is this like a milder form of long COVID? Because clearly they're in shape, clearly they look great, but when they're competing, they're not, maybe some of them are not quite at the level that they used to be.
Well, I think you raised two very important points. When you asked me earlier about risk of going on and developing COVID and what the long-term impact may be, here you got some of the finest fit people in the world. So that's
why I brought it up.
Yeah, I know. I think the issue around the immune response in the host and things like inflammation, the fact that you can actually find that your body's ongoing activity, and we've seen this with people who, again, it's chronic fatigue, but chronic Lyme disease, people have talked about this kind of same concept. And we really, I think, are at the opening of what I think will be a huge, huge effort to really look more at the long-term impact of immune response on something once it gets triggered. Remember, our immune system is like skating on a razor blade. You want to make sure anything that shouldn't be there, but you want to protect everything you can that's yours, and you don't want anything to happen to it bad. And where that really gets interesting is, for example, in pregnancy, where, that fetus is not totally all that mother, but at the same time, the body is working to protect that more than it's done anything ever to make sure nothing bad happens to it. And when that dysregulation occurs, where the immune system tips a little bit more on one side or the other, you can see ongoing problems. And I think that's what this virus is doing, is creating this environment where this ongoing immune response is occurring. And I think and it's not just one thing. It's a series of different issues. But I think the most important message is if anybody listening to this effort here is that there are people right now working on this, and that this is not something you have to live with, hopefully forever. Looking at drugs, treatments, what can we do to deal with long COVID? But right now, it's a daunting challenge, and I think the example you just gave very well could possibly be a part of a long COVID picture.
Now, long COVID, as described, as the way we're talking about it, is essentially people that feel like they're not the same now as they were before the virus. They never have recovered fully. Is that a fair way to?
I think it's really
or they
important.
were damaged.
Yeah, it's really important to distinguish. If you've spent the last 3.5 to 5 weeks in an intensive care unit, I don't care whether it was for an automobile accident or it was for COVID, you have a long-term recovery at hand. And it's going to take a while before you begin to feel like yourself again, what will happen. So you have to distinguish that, which is not necessarily, you can't get long COVID that way, but you also would just have that no matter what. Where it really becomes very clear is people who've had milder COVID, who then in the second or third week, thinking they're getting better, all of a sudden start feeling tired. They feel like they forget things. They're feeling this brain fog. And that's where it's really most noticeable, because these were people whose bodies were not, quote unquote, insulted in such a way with COVID to have been bedridden for days and weeks and, trying to recover from that. And I think that's the one example where you can say it's clear that there is a aftermath of this COVID for which some people experience and some don't. I mean, I know many people who have fully recovered from COVID and, they are doing perfectly fine.
Now, so you're saying some people with mild COVID still show some sort of a decrease in their physical response, like their...
Yeah. I've actually know people who had milder COVID, and they'll tell you that their long COVID was much more severe than when they had the acute infection.
But what do they mean by that? Like when
meaning when I had COVID itself, I was test positive, I was tired, but I was kind of around the house and, not feeling that bad. Now here I am 8 to 10 weeks out, And I some days feel like I can't get out of bed.
So something happened. And do we know, is it measurable? Is this like, can you get an EKG? Is there's something you can show? Or do they have a higher resting heart rate?
All of those things.
All those
come to play. And that's what these new centers that have been set up are actually studying. Is there a mechanism that can explain this, or is it a series of mechanisms? Why do some people have more cardiac and lung involvement? Other people have more brain fog, where clearly neurologically something is happening. Why do some people feel such severe fatigue and others don't? So one of the things is there's not a hallmark of long COVID that just says, if you have this symptom, and this symptom, you have long COVID. It's a combination of different conditions that are happening to people.
And are there any methods that they're utilizing that seem to be effective in treating people that have this?
At this point, we're just in the infancy of that. And that's, as I said just a moment ago, this is going to be a critical part of our ongoing efforts with COVID, is just the study of and trying to understand what's happening. First of all, as you pointed out, we have to know why you're having these findings, what's going on.
Right.
And then once we do that, what can you do about it? What kind of treatments could be effective? And giving people hope, because I've seen people who at 12 months after their COVID infection who are feeling like they've kind of lost their life. They don't have the energy to go to work. They don't have the energy to be with family. And this is really a challenge.
And have you read anything about hyperbaric therapy in relation to recovery from this?
I haven't.
You haven't?
No.
Have you read anything about, is there anything else that stands out, like stem cells or anything that they seem to think would be effective?
I think right now it's in that stage of just trying to define what it is, before they can even know necessarily the interventions that they can look at. What are the markers? How is your immune system operating? Do you have evidence of certain immune markers that are elevated? Why might you have some evidence of some heart involvement or your lung involvement? So part of it is right now just taking very seriously that long COVID really exists, and that we're trying to figure out first and foremost what might be the mechanisms that are causing it. And then I think you're going to see a large number of efforts trying to address treatment itself.
So it's still ongoing?
Still ongoing, absolutely. And, one of the things that's going to be a challenge is to find out how many of the people who had Omicron, even in their mildest stages, that go on to develop long COVID. We don't know that yet.
It's such a strange term, long COVID.
I know, yeah.
Because it's like you don't really have COVID. Your COVID is done, but you have the deterioration of your physical abilities.
Yes.
Yeah. Very strange, right? Is
Yeah.
there
Well,
another disease
we saw
that's
it
like
again,
that?
as I said, with chronic fatigue syndrome. That's
Right.
a term that many people have had to suffer with for years and years and years. And, we didn't have the major research initiatives around that I think COVID now is drawing the resources towards. And hopefully, people who have that condition also can be helped by learning what did COVID do? Why did COVID cause this?
Are there any, I know there's some new treatments that are on the horizon that Merck has and that Pfizer has. There's a bunch of different antiviral medications and pills that they're putting forth. Is there anything else I think there's also, isn't there an attenuated vaccine, an attenuated form of the virus?
Yeah, well, first of all, let me just say, I think the treatment area right now is a very exciting time in development. I look back to my work in the early 1980s in HIV/AIDS, and at that time, a diagnosis of HIV was a death sentence, simply a death sentence. And with the emergence of drug therapies, even in the absence of a vaccine, we've taken HIV for many people to a managed chronic disease. And I think that, as we look at the vaccines, it's clear we have challenges with waning immunity. How well will they work? How many booster doses can you give, et cetera? And so vaccines remain really the foundational response for dealing with COVID. But I think the drug therapies are going to become really, really critical. And we're learning more. I mean, for example, I know a topic that you have been of interest about and the show, that ivermectin. There are 5 big trials going on right now. They're going to be announced, the results, in the next weeks to months, that really have looked carefully at ivermectin, including high-dose ivermectin. And, I've, again, as a scientist, reserved judgment. I didn't close my mind and say, no, yes, whatever. I want the data. And we got to have these double-blind, placebo-controlled trials, studies where neither the investigator or the patient know which they got, and then objectively find out what's happening. I think there's a whole series of drugs coming down from several companies that surely have that potential if given very early. And the one you mentioned from Pfizer, for example, Paxlovid, while it has some contraindications with underlying health conditions that might already exist, on a whole, it is really a very, very fantastic drug. But the problem we have right now with that is that we have many, many places in this country where during the surge of Omicron, I couldn't get tested for 3, 4, or 5 days.
Why is that?
Because we just didn't have the testing capacity.
But doesn't that seems like something that would be much more easily?
Well, that's what I'm going to. Okay, that's exactly you've hit my line for me. Thank you. Okay, is the fact that we need a comprehensive system with surges, where in fact when a surge occurs, you can scale up quickly. So if I need to get a test done, I can get it done the same day and get a result back the same day, and then I can get into a system automatically that makes sure I get these drugs. If you're someone in the community, and one of the things that I have been so challenged by is what this has done by race. I mean, this disease has been cruel. If you look at the number of deaths, if you look at blacks, twice as likely to die from COVID as whites. Hispanic, 2.3 times as likely to die from COVID as whites. American Indian, Native American, 2.4 times.
Isn't this, hasn't there been correlations drawn between vitamin D deficiency?
There has been some, and again, this is another area of study that needs to be done. But I mean, if you look at these issues here, getting the drugs to those populations, okay, what can we do, whatever their risk is, so that if you have a community where I don't have a doc, I don't have one. I don't have access to health care in general. I go to a community clinic. So what I think this whole issue around drugs, the point you just raised, is really highlighting is now's the time to address this issue of health disparities and just generally our healthcare system. We have a disease care system. A disease care system, not a healthcare system. And by the way, it has been under attack for 2 years. It's incredible what's happened.
By COVID. Yeah.
By COVID. I mean, what it's done to care in general and what's done to our healthcare workers, okay? So we need to take a look and step back and say, okay, so what could we do to improve on that? Well, keep the vaccines, but we know we're hitting a wall on that, okay? Some people are just not going to get vaccinated no matter how we try to share the information. But we should be able to get people to understand if you do get sick, these are the drugs that can be helpful. This is how you get them quickly. And try to reduce the hospitalizations, the serious illness and deaths, and make this more of a treatable type disease, like I talked about with HIV. And the impact in the communities of color, for example, will be huge if we could do that. And it would improve healthcare in general. So to me, that's one of the things I'm working on right now is trying to understand surge capacity for testing. Let me give you one last example I think that helps illustrate this. If you look at the fire departments in the state of Minnesota, one of the best well-funded fire departments in the entire state is the Minneapolis-St. Paul International Airport Fire Department. And thank God we have them. I support every penny we give them to keep that fire department going. Large number of units, people well-trained. We've not had a plane go down there on the airport itself since its inception, any big plane. The two that did went down in South Minneapolis in the 50s and were handled by the Minneapolis Fire Department. Well, we pay for that every day because we wouldn't operate that airport without them. We should be paying for test capacity. So if we have a lull in it, it doesn't mean that everybody gets laid off or we don't do that. We use them for other things. But as soon as that surge occurs, we could put testing back into place. So everybody can get a test that first day. And I don't care where they live. I don't care who they are. They can get on those drugs. And Joe, we could do so much to reduce, if not eliminate, the serious illnesses, hospitalizations, and deaths just with that alone.
Just with testing.
Just testing and then the drug availability, the drugs you just talked about. I mean, I think we're going to see more and more drugs become available that I think are going to have real positive impact. So I see this as kind of the silver lining of this pandemic is that people are now beginning to do that. And we can do that around the world. If you know anything about HIV drug distribution, some of the most remarkable improvements in health have been in Africa. where we've been able to distribute these drugs for HIV day in and day out. So we surely can do this for a COVID-like situation. So that's what we need to focus on, and that's where we need as a global community understand how can we improve testing so that we make sure we get people on there, and then how can we make certain that they get their drugs.
Now, you covered a whole bunch of things, so let's start from the beginning. First of all, you talked about testing. Now, one of the things that I thought was shocking, I was watching this press conference where Ron DeSantis was addressing the claim that they had let a bunch of COVID tests expire and that they were no longer useful. And I was like, wow, I didn't know COVID tests expired. So they have a shelf life?
They do.
Why is that?
Because basically the reagents in there can degrade over time, and you want to make sure you have exactly the right ones. So they do have a shelf life.
So they must be manufactured in accordance to the need, and they're going to have a surplus, and then you have to abandon those, but you have to keep up the supply.
Well, and also it's not just surplus, but we do what we think called vendor management control. So, you basically rotate it in your shelf. So you have a place that says, okay, I will help vendor manage your product. So I'll make sure that of all the locations out there, somebody's not sitting on some stuff and others are using more. I'll make sure that the one closest to outdating gets out there,
right,
and the ones that are farthest back, basically, I'll hold so that we don't lose. And with vendor manage, you can do a lot to actually reduce that problem.
So that was the accusation from the Florida administration, that they hadn't distributed those things. They could have done that and got them out there before they expired, and it seemed like they were hoarding them.
Yeah, and clearly this, again, is part of that whole testing issue. Is some of it's going to be surge capacity, because there's only so much you can actually put in surplus stock, with the fact that some of it basically will, in fact, expire. And so then it's a matter of, okay, so what's your surge capacity? How do you then say, I can bring on board, and you can't make it at the last minute. It's kind of like a fire department that goes out and tries to buy their fire truck when the 911 alarm comes in. And so you got to have people ready to go. You have to have manufacturing capacity to go. So when you have a surge, you can do that. Now, here's the challenge. If you believe that Omicron is the last of the variants, you believe that COVID is done, why would you invest in that? And that's where I come back and say, well, I hope it's the last one, but hope's not a strategy.
Right.
You got to be prepared. What if another variant shows up? The challenge is, again, we're going to have the same needs. We're going to have the same issues ahead, so we're going to have to plan for that.
What kind of shelf life do those tests have?
It varies. I can't tell you test by test, but it's months, but it's not years. It's not years. Yeah.
Let's go back to vitamin D.
Sure.
So when you're talking about how disproportionate amount of Hispanics and Black folks and Native Americans, essentially people with more melanin in their skin, people with more melanin in their skin have traditionally had lower levels of vitamin D that live in urban areas, especially in like cold climates where they're covered up. How much of a correlation do you think there is between low levels of vitamin D and more severe COVID infections?
Well, I can say that there clearly have been studies done that demonstrate reduced vitamin D levels in cases coming into the hospital.
It was like 84% at one point in time of people in the ICU had insufficient levels of vitamin D.
Yeah, and I can't comment on it. The question we have with vitamin D, is it a marker for something else? Meaning people who have adequate vitamin D, is it because of their behavior, what they eat? Is it because they have access to certain foods, etc.? What does that mean? And so we still have to figure that out. But
well, vitamin D isn't really like effectively supplemented through food, is it?
Well, sunlight and some degree food, meaning I take a supplement. So I'm talking about taking a supplement. If you're basically living from paycheck to paycheck and you're having a hard time just feeding your kids, are you as likely to go buy vitamin D to supplement? That's what I'm saying. So it's that kind of issue there. So, but I think the point that you're raising here is, again, this is another example of what the kind of studies we need to say, could that help improve? Much like we did with niacin and milk and so forth, where we basically were able to show that we can get health benefits in some cases by supplementing food.
Don't they supplement vitamin D in milk as well?
To some degree, yeah. Well, milk has just a higher level. But I think the point being is exactly what you're raising, is this is another example of, can we have an indirect benefit to the public by learning this and actually helping people have adequate levels of vitamin D. I think that's critical. But I do want to make one comment on this, because I think this has been sometimes misunderstood about race and the issue of risk for COVID and for serious illness. If you look, the real correlation, which again is not cause and effect, but is who are the frontline workers? Who are the people that are left largely unprotected? Who did the critical service for us, even in healthcare? During the course of this pandemic, it was often, our communities of color. And people from that community, I could stay home and work in my computer in my office at home. I didn't have to be out and about. I didn't have to sit there and have close contact with the public. And so one of the challenges also is, of course, how do we protect these people from a work standpoint? And that's why getting vaccines to them is really, really important, and supporting the issues. And we've seen some really novel ideas. Probably the most, in fact, you would find this interesting, is the fact that one of the most novel programs I've seen has been a new movement among black barbers and black stylists, who basically work to talk to their clients in their chairs, and who trusts people more than your barber. And they talk about all issues of health. And it's a program that was started out of the University of Maryland, and it's been fascinating of how it's actually having a really positive impact on health. But they do kind of like what you do, talk about all the health issues.
Wait, I'm confused. So you're saying there's a program to educate barbers to talk to their clients?
There actually is. And then they actually look at the outcome in their clients. And they've been able to demonstrate major increases in people getting vaccinated, people seeking out screening for cancer issues, et cetera, because the barbers use that time when you're sitting in the chair, or the stylist, to talk about health.
So how are they doing this? Through seminars? Like, how are they educating these people?
It's a major program. Dr. Stephen Thomas, who heads this up, who is just a very creative, innovative guy, and it's starting to spread around the country. It's actually one we need to replicate in other places, where you can actually get the message out to help people. Where do they hear it? Well, I heard it in the barber chair. Well, who do you trust more? Well, I trust my barber.
I don't know. Well, I don't have a barber, clearly.
I kind of was making that inference when I was talking about this when I started.
But when I did, I had a lady cut my hair, and she was great, but I wasn't taking medical advice from her.
Yeah. Well, if she was highly trained, it may be a good time for you to listen.
Maybe. I don't know. She told good stories, but, So when you're talking about frontline healthcare workers, one of the things that is a real point of contention is folks that were frontline healthcare workers that were infected, that recovered, and then they were facing vaccine mandates. What are your thoughts on that?
Well, first of all, I think it's critical that we add in previous infection as a dose of vaccine for certain.
So why didn't that happen with those
Still working
folks?
on it. Still working on it.
I know, but in the middle of a pandemic, when you desperately need these people that risked their lives in the early days of the pandemic when there were no vaccines.
Yeah. Well,
and many of them were infected with COVID, recovered, and had robust immunity, but yet they were fired because they refused to get vaccinated.
Well, let me add a little more detail to the story. It's not quite that simple.
It's not?
No, it's not. And again, I'm already up front saying I believe that to be considered fully vaccinated, or whatever status you're going to call it, you should at least include previous infection as a dose. Now, I shared with you a few minutes ago that it's been very interesting. If you look at either Alpha, Delta, or Omicron, it mattered which variant it was as to who did better. People who clearly had previous infection, or people who had previous infection and were vaccinated. And across the board, people who were infected and had vaccine did much better. Okay,
infected and then got vaccinated,
and then got vaccinated. Added one more dose on, and it really did boost them up. And
how do you study that?
Basically, so we look at people then who, during the Omicron surge, who got infected. And the data are actually out there right now looking at that. And in fact, if you look for deaths, for example, if you were unvaccinated, your deaths during this most recent was about 974 per 100,000 among people infected, okay? But if you were fully vaccinated only, and you got 0.71 cases per 100,000, big drop, and then fully vaccinated with a booster was 0.010, much lower even yet.
And this is death.
Yeah, this is death. Okay,
and you're talking about death from Delta?
in this case, this is even Omicron. But the point I'm trying to get at is if you looked at the array of these, those who had previous infection and were one dose, like a boost, actually did very well. So I'm willing to count a dose. But let me tell you why I have a problem with healthcare workers who aren't vaccinated. And I support healthcare worker mandates. If you look across the board, 99% of doctors got vaccinated. They did. I mean, the data are there. Where we saw the lesser levels of vaccination were in the technician group. Nurses, not as high as doctors, but were there. And why is that important? Because we were able to demonstrate, particularly with Omicron, a number of outbreaks or ongoing transmission of cases in healthcare settings where it was the healthcare workers bringing the virus in and transmitting. And where we looked at that, we saw data, and there's several studies coming out very shortly, looking at people who were hospitalized, negative upon admission, not there for COVID, who were there at least 10 days, and then got infected and got seriously ill. Well, they had to pick it up in the hospital. And there were two sources. Basically, somebody coming in from the outside, i.e. visitors, who in most cases didn't exist, or healthcare workers, or they got infection from other patients.
Yeah.
And
that's three, right?
When it comes, it's the outside, inside kind of thing. So when it comes to patients, often these people were highly segregated. They were in totally different segments of the hospital. Healthcare workers had to play a role there. So our point in getting healthcare workers vaccinated is not just to help protect themselves, but it's also to help protect the patients.
Right. But isn't it been proven that people that are vaccinated also catch COVID and also spread COVID?
They can, absolutely. And we should, but I'll tell you right now that if you were previously infected and you had that dose, you're going to be much less likely to actually get infected yourself and spread the virus.
That's true?
Yep,
so it's not
true.
just that you're less likely to die, but you're also less likely to get it and spread it.
Yes, exactly.
By how much? What factor?
I can't give you the exact data, but it's substantial. I don't have it right in front of me. Okay. It's very substantial that you can get protected with that infection and dose. What the debate has often been for healthcare workers, they feel like they didn't get credit for that previous infection.
Right.
And I'm saying they should.
So you think that the healthcare workers who've had a previous infection should get one dose of a vaccine?
Right. And I think we should look at that carefully as considering that fully vaccinated.
And do you think that it matters whether it's Pfizer or Moderna? Moderna's a stiffer version of the virus, correct? Or the vaccine. And then Johnson & Johnson is different as well, right?
Right, it is. And right now, clearly the evidence points to the fact that Moderna gives us a bit of a better take than we see with Pfizer.
Because it's stronger.
It's stronger. Now, where J&J is interesting and complicated is the fact that if you look at its response initially, it's not nearly as high. It's in the low 80% level, where the mRNA vaccines are in the high, mid to high 90s. But if you look over time, the J&J levels don't decrease. They actually go up some. And the actual level of protection for the mRNA vaccines will decrease, where we see that waning immunity at 4 to 6 months.
Could you explain that to people, how the difference in the J&J works? Because it is an mRNA vaccine.
It's not, it's what we call an adenovirus platform. It uses that to basically get into the cell, to have the cell make basically the spike protein that you then get your immune response for. But it looks like the J&J vaccine may have more positive impact on a thing we call T cells, a type of immune cell, than we see with the mRNA vaccines. Again, all emerging new science we're learning about. I think if I had to make a prediction in the near term, meaning 6 to 12 months from now, we very well will be likely talking about the preferred heterologous vaccine approach of using one dose, for example, something like a J&J, and then a dose of mRNA. I think that's really a possibility. Because
this is just speculative?
This isn't speculative. This is based on more and more data we're seeing accumulate that may really be a possibility. And in fact, it's also in this issue that I happen to have an intense personal issue, because our center, the CIDRAP, Center for Infectious Research and Policy at the University of Minnesota, is actually going to be leading, and it'll be announced very shortly, what we call a pan-coronavirus vaccine roadmap process. We just completed a 2-year effort to come up with a detailed roadmap for how to get new and better flu vaccines, all the way from research and development to marketing, licensure, et cetera. And we're trying to get new and better flu vaccines, and we're working on that. I think you're going to see version 2.0, 3.0, and 4.0 of the vaccines in the next few years. The vaccines we have now, are remarkable tools, but they're not perfect. And I think you're going to see an evolution, just like with drug treatment, better and better vaccines coming out over the long term.
One of the things that I read was that one of the problems with accepting natural immunity due to previous infection is that different people had different levels of the disease, and that some of those very mild infections did not impart enough of an antibody response, and that these people were not as protected as maybe they thought they were. Because even though they had tested positive for COVID, they really didn't have that much of an impact on their immune system. Is that?
That's an important point, but let me just add a qualifier to that. When we talk about measuring antibody, I don't know what we're doing. And what I mean by that is that we don't really have a correlate of protection today. There's different kinds of antibody. There's neutralizing antibody. There's total antibody. Okay, all these different kinds of antibody. There's the different kinds of T cells. And what we're doing is taking one test and saying, how high is this here? Well, does it really correlate with protection? And this is what we call a correlate of protection. So, for example, I can tell you if you get a measles vaccine and I do a blood sample on you, I can tell you likely if you have the immune response that's going to protect you against measles. I don't know what a protective level is here. So when I talk about it, I know that work is going on, and I think you're going to hear a lot more about correlates of protection in the months ahead. But I'm looking at just from practical experience. If you've had COVID before, are you protected or not when you are exposed again? And compare those who were vaccinated after having had one episode, those who only had an episode, and those who had nothing. And then let's follow them forward. And that's where the real proof in the pudding is that do they get clinically ill or not? Do they get infected? And that's where we're showing right now that I can't distinguish people who've had a really severe case of COVID versus those who have had milder cases of COVID. Maybe over time that will emerge. Clearly the antibody levels are different, as you pointed out. They are. But I don't know how that response to protection.
Interesting. So just because antibody levels are high doesn't necessarily correlate with superior protection.
At this point, we can't say that. What we can say is it's likely you have more, but it's a combination of all the parts of the immune system, the B cells and the T cells. And this is where, if I always jokingly say, if you really want to talk about something complicated, hell, rocket science is easy. It's immunology. You want to know science, it's immunology, okay? Because this whole immune system we have is so complicated.
Right.
And so to me, the science you're going to see coming out of the immunity related to COVID is going to, I think, bring us some really exciting developments. HIV/AIDS did that in the 80s and 90s. We learned a lot about the human immune system. I think this is the next best opportunity here. We're going to learn so much about human immunity from just trying to understand how to protect against COVID and how to respond to long COVID.
So immunity as a whole is a very comprehensive and wide-ranging thing, right? Because it's immunity to all sorts of different diseases and viruses. And do you anticipate in the future that we can figure out how to boost overall immunity? So it wouldn't just be immunity to COVID, but immunity to flu, immunity to all these different things, common cold, like that. Sometime we could get a grasp of the immune system to the point where we could elevate your levels of immunity for all infectious diseases.
Well, let me just add that that's a really plus-minus situation. And what I mean by that is that there really isn't a term natural immunity. Everybody uses it, so you're in good company, okay?
Sorry.
But no, you're in good company. But if you go to any textbook of immunology or anything in epidemiology, there's no term natural immunity. Immunity is immunity. It doesn't matter whether you get it from actually being exposed to the virus or you get it exposed to the vaccine. How your immune response happens is it happens. But there is another kind of immunity called innate immunity. And that's where if today I get a sliver in my finger, okay, if there's bacteria all over that sliver and I'm starting to get an infection, there are cells in my body that don't recognize that anything other than this shouldn't be there, and then it responds. Now, they're not very effective overall. What you want is the very effective specific. They recognize that bacteria. So, if I get an infection with something, the immune response is I'm going after that specific part of that virus because I've been trained to do that. So when you say about boosting the whole immunity, you got to be very careful because, again, what we don't want to do is cause an immune-related disease, like the trigger that might be happening with COVID, to up all of the immune system in a way that causes you to have this overvigorous immune response. So I think you're going to always come back to the specific antigen or the specific piece of a virus or a bacteria that you're going to want to go after. And you're not going to have one kind of monolithic vaccine because that will elevate everything, which could trigger these bad things, and it won't necessarily give you the specific lock and key with that one virus. And so I can't say I see the overall boost. What I do see, though, is more work on how do you handle so many different infectious agents. Or for that matter, I think one of the areas you're going to see a lot of work coming out in the near term is on cancer. Cancer vaccines, I think, have a huge future because you can detect those cells that are just starting to emerge that are cancerous. Let your immune system clear them out.
So what kind of work is being done right now on cancer vaccines?
Oh, a lot of work.
Was it an mRNA platform?
Well, that's, how mRNA's got all their initial research effort was for cancer vaccines. That's how the first real efforts were put into place by the NIH on these vaccines. And I think that one of the things, particularly for people who have specific risk factors, genetically, they're predisposed to breast cancer, they're predisposed to these things, if you could pick up certain changes in the cells that indicate this is a precancerous cell or an early cancer cell, imagine if you had a specific, kind of police officer in your body that could help identify that and take it out.
So a general immune system response is not enough. It has to be a specific immune system response for something that you're looking for.
To make it most effective. Right.
Make it most effective.
Yeah.
Is there anything that's being developed that works as like a general immune system response that enhances general immune system?
I can't say other than just being healthy. I mean, malnutrition is a good example where basically, you really have a major compromise on your immune system. That's a real challenge. Stress has been shown to challenge your immune system. And so I think it's general things like that. Again, I'm not an immunologist, but I'm curious for my own self, if nothing else, what you can do that way. So I think those are the issues that right now there's not one thing.
When you look at these cancer vaccines, how far off are they from being deployed?
Well, it's not somebody in the cancer area, but only familiar with the work that's going on. From my colleagues in the cancer side of the house, they seem, it's still early, but it surely has a potential future.
Now, when it comes to side effects and adverse effects from vaccines, what is causing that?
Well, again, we don't completely know, but for example, the myocarditis piece has come up over and over again as likely an immune response that's occurring, okay, that it in itself is causing this immune response to attack part of your heart muscle that would cause that.
What part of the vaccine is causing that immune response?
Well, that's what's not clear yet because it's when I say it's not clear, it's not just the spike protein, obviously, because that in fact is, a lot of people have that response to that. And so I can't say, again, not being a clinician immunologist, I can say, though, that, when you look at the seriousness right now of myocarditis, my job is to try to figure out, well, is this really a deterrent to getting vaccinated? And, we can show time and time again right now from study after study that, in fact, the risk of myocarditis is greater in getting COVID by far than it is to getting the vaccine, much greater.
Isn't that different, though, with different ages and also with different vaccines? Like, hasn't it been shown that, particularly for young boys, the Moderna vaccine is more problematic than the Pfizer one?
Absolutely, it has been. Yes, it has been. Absolutely.
And isn't it shown that with the Moderna in particular that there's more of a chance of myocarditis from the vaccine than it is from the virus?
No. Actually,
No?
At this point, that's where we were looking at it may be close to a trade-off there. But you don't take into account pericarditis. You don't take into account arrhythmias, all the other things that the virus does to the heart, which we never talk about. And those are actually very substantial and are as much of a burden in many cases as myocarditis. So you have to factor in, what does COVID do to your heart? What does the vaccine do to your heart?
Does the vaccine cause any pericarditis?
No,
or
none. We've
none?
seen zero. Zero cases. Zero
Really?
cases of pericarditis, zero cases of arrhythmias. But
Zero.
the virus does it.
Zero.
Zero.
That's wild. Yeah, I have a friend who was a very healthy guy who wound up getting some strange heart condition from the virus. And he was shocked. And one of the reasons why he avoided the vaccine is because he's worried about a heart condition.
Yeah.
And then he wound up getting a heart condition from the virus itself. Now, what causes this response in the heart tissue? Because myocarditis is an inflammation of the muscle in the heart. Like, what is causing that from the virus?
I don't know.
Really?
I don't know. I mean, this is ongoing studies right now looking carefully at that. And it's surely a major area of study right now, but I don't know.
Is there any understanding of what could be done to prevent it? Is there anything that, like, when someone is infected, that it shows that certain nutrients or certain medications have been known to impart some protection from that?
You know, I'm not aware of any nutrient issues, but I want to point out, just so people are aware, if you look at the serious outcomes of particularly vaccines, there are only 2 cases of myocarditis that are currently under investigation that caused fatal outcomes. Out of all the millions of doses of vaccine, 193 million doses they've looked at in these age groups. And so
There's only 2?
Two currently under investigation.
But does that mean that there's only 2 instances? Or is
Two
it mean
instances
only
where
2
people
that
have died?
people are studying?
Well, studying in the sense that we know about. When I say studying, they haven't even yet confirmed that that really is caused by the vaccine. It's being looked at right now. We're more clear on the thrombosis from the J&J, the blood clot issue. That
And
clearly
what caused that?
Inflammation. How the inflammation occurred, why it occurred, I can't comment. I don't know. But I can tell you that even there, if you look at those, it's still, from the J&J perspective, the risk of a bad outcome to your heart or to your, basically the thrombosis is still greater overall from getting the disease. Now, at this point, the J&J vaccine has had a warning put on it, a black label warning about the fact of thrombosis, which I think is important. But as we have shown over and over again, data-wise, particularly in many parts of the world, the J&J vaccine is a real advantage vaccine because of the lower dosage, the more stability of it, and the fact that overall the health benefit's going to be much greater than not having the vaccine.
Didn't I read something that was pointing to the potential ceasing of the production of the J&J vaccine?
Yeah, they did, but it was in part, and I don't have primary knowledge of this, that they actually had enough inventory that they didn't want to have outdating kinds of things happen. So my understanding, it is not permanently shut down. It's on a holiday.
They have a surplus.
They have quite a surplus, and so they had more than enough, but they're putting the vaccine out. And they will continue to make it. It's not they're down.
And it's they continue to distribute. Is it still a 1 dose, or are they thinking of it as a 2-dose thing?
1 dose with what they call a booster.
Right. But
Yep.
why do they call it a booster? I mean, if it's
I don't like the term.
Yeah.
I've been really opposed to that from the get-go. You know, in August of last year, I was one of several people who came forward and said, look at the waning immunity data. It's clear that at 5 to 6 months out, we're seeing an increasing number of people who previously before seemed protected, who are now getting infected, who are getting seriously ill and hospitalized. And it's because it tends to wane at 4 to 6 months. So I very strongly urge that, in fact, everyone get, at that time they called it the booster dose. I think CDC should change the definition of fully vaccinated for the mRNA vaccines to 3 doses, skip the booster concept, for the J&J 2 doses. And then for those who are immune compromised, they surely should get a 4th dose. Absolutely. They should get a 4th dose. The data we have says that does boost even better, it's successfully there. But I think that right now we should be labeling people with 3 doses and don't call it a booster.
What do you think is going on with Israel?
Well, Israel actually is a very interesting situation in that it is both the best of science and the worst of times. And what I mean by that is they only have a segment of their population vaccinated. They have a relatively high percentage not vaccinated.
Well, I thought they were one of the most vaccinated countries in the
Well,
world.
they are among the vaccinated. That's the whole point. They are actually where they're now doing fourth doses among many people. But if you look at the recent big uptick in cases they had, it was almost all in unvaccinated people.
That's not what I read.
Oh,
I
it
read
is,
this
it is.
whole thing about vaccinated people in Israel, like that there was a giant surge of vaccinated people.
No, the surge
catching
is
COVID.
primarily in I don't have the numbers in front of me, but the surge is primarily in unvaccinated people. There surely was an increase in cases in vaccinated people who had 3 doses. That's why they went to 4 doses for older populations, et cetera. But the real burden, the major thrust in this surge in Israel was, in fact, unvaccinated people.
That's confusing to me because I'm almost positive that I read something that was talking about the confusion that they're having because of the amount of vaccinated people that have been infected with COVID, and that it's a giant percentage of the cases. I didn't read anything about it being primarily unvaccinated people.
I just did that.
Can we see if we can find something
Yeah,
on that?
go ahead. I just
Because
did that
that's
in my own
fascinating.
podcast, by the way. Okay, I just did I covered that about 2 weeks ago, and I actually had the numbers in front of me. And I actually went through what percentage were unvaccinated, what percentage were vaccinated. Clearly, the vaccinated did see increased numbers of cases, but the surge was really covered by the unvaccinated.
So there's an enormous surge, but it's because of unvaccinated people.
Yes. We can look it up.
See, that is so confusing to me because I was almost positive that I had read that an enormous percentage, like a very high percentage of the people that were new cases that were infected with COVID were vaccinated.
They were increased. But again, the big surge itself, and particularly in hospitalizations and deaths, were in unvaccinated people. We can get it here looked up here.
Yeah, we're going to find
Good.
it. See whatever you can find, Jamie. You got anything?
Sorta.
Sorta?
I mean, I think it gets. Here's the first thing I found, which I don't know, like the efficacy of this.
Analysis of
information.
COVID vaccine breakthrough infections in highly vaccinated Israel. Okay, a recent study published in, what does that say? MedRxiv. Preprint server. Researchers evaluated model age structured cases of severe acute respiratory syndrome, coronavirus 2, vaccination coverage and breakthrough infections. To do this, the researchers data Ministry of Health.
So I don't know if
This is an older piece. Yeah, this doesn't give it to you. This is
January 13th.
Yeah, but I mean, it's in terms of the Omicron surge, there's more data that's come out on that issue.
Right, but this is only a month old.
Yeah, I know, but if you look here,
I just Google then.
unfortunately, my research assistant's outside the door. He actually has the papers in hand. So,
Well, let's see what we can
we'll
find
get you.
under
We'll get
anyway.
you the data and show you that, okay? And that you can take a look at that. That's an
Highly
old. That's an old one.
vaccinated,
That's
is
an
it?
old one. That's an old one.
Okay,
Yeah. You got to have
What's
a
in
late
that first,
January.
Let's go to that January one and see what it says, though.
Yeah.
Like it is an analysis, and we only looked at the top. About the study,
Yeah.
the following data sources received. Okay, March 21st to November 6th, 2021. Proportions of the various types of variants and concerns were also confirmed throughout the course of the study. The vaccinated class divided into 5 stages to mimic the diminishing of
See,
immunity.
these are all vaccinated people.
Mm-hmm.
This is not the unvaccinated. So you have what we're looking for are data that will actually talk about the number of unvaccinated. So what this study is
Right.
doing is an important study. What it's looking at is among the vaccinated
I
who
see
had
what you're saying.
breakthroughs.
Right.
Okay.
So
look that
maybe we can Google what percentage of people that have COVID in Israel are vaccinated.
COVID and Omicron.
Okay. So Omicron, which is how much more infectious is Omicron than the Alpha variant or the Delta variant?
Well, it's estimated to be at least 2 to 3 times more infectious than Delta, and Delta was 2 to 3 times more infectious than Alpha.
I had heard it was way more infectious than that.
Yeah, that's roughly what
just-
we've got.
Just guesswork.
Well, 2 to 3 is a lot.
How do they guess that? Is it dependent on? It's a scale based on, say, if you're infected, how many people you'll infect?
Yeah, how many? And look at households and direct contacts that look at that, and that's really the primary way to get it.
There's not a way you can look at the actual virus itself and
No.
say, oh, this is measurably more infectious. So
No.
it's basically in how many people it infects.
Yeah, that's it. It's a real experience of what happens with it. in the same setting between the different variants, what does it mean?
You got anything?
The first thing I found, it was blocked, but it said before blocked, it said that 40% of the population in Israel is unvaccinated.
Yep.
But
40%?
Yep.
Again, it's
Why did I see, like, I
me see if I
read that
can
it was
find it again.
80% that were vaccinated. Is that true?
No, that's right.
40%?
That's exactly what. Yeah, that's exactly, and that's the group that really had
So I
contributed.
click on this. It's going to disappear real quick. See, it said it. But
Yeah. Sorry, you have the right stuff
I'll
there.
try to
though.
find it.
That is the right piece.
Let me see if I can get it on
yeah.
the archive thing.
So
But anyway, I think the
it's-
message.
So that
I
means
think the
Israel's
message.
only got 60% of their population vaccinated?
Yeah.
I thought it was way higher than that.
No. So I think the message, though.
Lags behind on COVID. 40% of Israelis have no protection against COVID.
Yep.
But isn't that
Oh, it's the Omicron variant, it says.
Yeah.
right? But how does that work then? I mean,
Right.
is that because Omicron evades the protection of the original vaccine?
It does, and it also evades the
So is-
protection
but
of
is
previous infection.
But is that like, put that article up again? The way they're phrasing that, is that a manipulation of language? Because if it's saying 40% of Israelis have no protection against COVID Omicron variant, but are they vaccinated from the original variant? Because if they're saying that they don't have any protection, are they saying that because they don't have protection because they don't have antibodies for it, or are they saying they haven't been vaccinated?
I can't tell you what that headline is saying there.
It's weird though, right? The way they're phrasing it?
All I'm telling you is that if you look at the proportion that had no vaccine, those that had full vaccination but no booster, that's what they were trying to compare.
So that is what they're saying. So look, it says 1 million refused the booster,
Yep.
while just 110,000 out of 1.2 million young kids got the vaccine. That's a lot of language there.
Yeah.
I recently found something when I was looking that said that this is back in the end of the summer that enough doses had been administered in Israel to get 99.3% of the population vaccinated.
Yeah.
That was enough but it doesn't mean that they were.
No,
Well, see, the thing-
it's also because they also counted a dose to person, and if you get 2 and 3 doses, you take it away from somebody else. So
Well,
merely having 100 million doses and 100 million people doesn't mean you have 100 million people vaccinated.
Well, they also don't count you being vaccinated if you're not boosted.
Well, they do, but they don't count it as fully vaccinated.
Right.
Yeah,
They have a green card situation or
Yeah,
whatever what's their term that they use?
I don't know what it is.
So with them, you must be boosted to be termed fully vaccinated. Is that correct?
Right.
So
When looking, this is what pops up for what percentage is vaccinated. But
it's enough to have vaccinated 99% of the country's population, but it doesn't mean that they did it.
Exactly.
Okay. So you said that Omicron, so part of the reason why that article was phrased that way is because Omicron evades the protection of the vaccine.
It does evade protection of vaccine, and it evades the protection from previous infection at a level that the other variants hasn't done.
If that's the case, then what is the benefit of getting vaccinated now?
Oh, there's still very substantial protection. But if
it's evading the protection of the vaccine, what is the protection it gives you?
Well, again, let me point out, these are numbers I said before. If you just look in this country for the issue of, this is during Omicron, if you look at deaths, again, the point I made earlier, if you're unvaccinated, your rate is about 9.74 per 100,000 population, 9.74. If you're fully vaccinated, it's 0.71. But if you're fully vaccinated with a booster, it's 0.01 per 100,000.
But how is that possible if it evades protection of the vaccine? If you said 100% of all the cases, nearly 100%, are now Omicron,
Yep.
but Omicron evades the protection of the vaccine.
But not for everyone. It reduces it. So what we're talking about...
It reduces the protection of the vaccine?
Yeah. So, for example, with the booster, you can boost it back up. If you look at, for example, fully vaccinated, 2 doses, or you look at it versus 2 doses plus what some would call the booster, you had 8 times as much protection with full vaccine and that booster than you did just full vaccine.
From Omicron?
Yep.
So then how is it not protecting you from then how is it evading the vaccine?
Well, the evasion is not complete. It's limited it. So if you take something from 95% protection to 78% protection, we call that evading immune protection. But you're still getting substantial protection for most people. So that's a term that is not very artful to say the main immune evasion doesn't mean that it's yes or no. It's like a rheostat. And so what we're concerned about is that goes on over time, that immunity may actually continue to lower and lower and lower. And that's what we're trying to study right now is we can't boost our way out of this pandemic. Are we going to need vaccines every 6 to 7 months? We don't know. But that's when I talk about by waning immunity.
So the booster helps something from Omicron. It helps you avoid severe illness?
Yes. That's what I just gave you just now were deaths. But if you look at hospitalizations, the same thing, okay? If you look at, these are data from December 25th for the United States. For hospitalizations.
And this is gauging like how many people who were admitted were boosted versus how many people only had 2 shots versus how many people were unvaccinated.
Right. And I don't have the data on the boosters for those data here, but if you look at for unvaccinated people for hospitalization, it was about 79.6 per 100,000 during Omicron. If you were fully vaccinated, it was only 4.4 per 100,000. So 79.6 versus 4.4. If you're boosted, it even takes it down lower.
And does this factor in comorbidities? Does this factor in all the things we talked about, like low vitamin D, obesity?
It's all of it. There's not a distinction made. I haven't seen any breakouts. The best breakouts we get are largely those with age and some of the major comorbidities.
And what about previous infection? How does that factor in with Omicron?
In previous infection, again, also gives you more protection like a dose of vaccine, but it's not yes or no. Think of it like a dose of vaccine, and that's what it does.
Now, is there a possibility of an attenuated COVID vaccine?
It's possible, and in fact, I think many of the vaccine researchers are thinking, what can we get to really cause the upper respiratory protection, localized protection in your upper respiratory tract? Because if you can stop the virus there, you can stop it from going deep into your lungs and then going into the rest of your body. Clearly, people are looking at what vaccines would work, and our previous experience would suggest that live attenuated, as you called it, which is something that actually grows, causes an immune response but doesn't cause illness, could be one way to go. Can't say that it's going to be the way, but it surely is something that everybody's looking at right now.
Is that in development?
Well, I can't say it's in development in the sense there are several labs working on it, research-wise, but development might say a little further along. But
Right.
I think it's going to be the future. I think it surely could be a big part of the future.
And when these labs that are working on it, have you seen promising data? Have you seen trials?
I haven't, not at all. It's far too early for that yet. I mean, I think part of the challenge we had was in January and February of last year, we kind of jumped on the mRNA bandwagon to the extent of saying this was going to be the answer. And some people will say, well, we didn't say it would protect against infection, but there was a sense it was going to really protect against infection at 95%. I think it was only really by the summer that people begin to realize that they're still very, very important and remarkable tools, but they're not perfect. These aren't going to necessarily be the final vaccines we need. And so it's really only this summer that you started to see more interest in, well, what other vaccines can we look at? What is going to be 2.0? What's going to be 3.0? And at this point, that really is now people are realizing we do need much more in the way of vaccine research. And that's why I mentioned to you our group is actually developing a roadmap for how do we get these new and better vaccines.
Now, what are your thoughts on the monoclonal antibodies?
Well, I think it's a very powerful tool. I think my concern, and we had an article in the SIDRAP News this week, and I covered it in my podcast this very week, the one that was...
What's the name of your podcast?
Osterholm Update. It comes out every Thursday morning. And I actually covered the issue that our big challenge right now is we're seeing it not being used. Even though we're down to one, monoclonal, as you know, the other two basically, because of Omicron and the mutations, challenging how well they worked. But we're sitting in a number of states right now where we have Paxlovid and monoclonal antibody that's not being used.
Why is that?
Well, that's the challenge. Is it because people aren't aware? It's because people can't get tested in time. And so therefore, you have to have it within that 5-day period. People actually get sick enough that they move into the hospital quickly and then therefore they're not eligible for it. Is it because they don't have access in their communities? I mean, if you don't have a healthcare provider, how the hell do you get tested and get the result back and take it to somebody that will issue a prescription for that drug?
It seems like if you're trying to reduce deaths and severe illness, that monoclonal antibodies would be an important part of that strategy.
Should be, absolutely. I couldn't agree more.
Now, why did they eliminate the first versions of monoclonal antibodies?
Well, the first two, actually, which were quite effective, it turned out that actually the mutations in Omicron basically canceled out their effectiveness because the mutations were where those two monoclonals really attacked the virus.
Was it a reduction of protection or elimination of protection?
Well, in the laboratory setting, it was largely almost an elimination of protection. And the challenge we have is we went through a period where Omicron wasn't everywhere all at once. And some people were concerned about the fact that, well, we should have taken them off the market right
because
away.
Because there's still Delta cases.
Because there were still Delta cases. And the problem we had is we just didn't have an adequate way to test people to say you have Delta or you have Omicron. Because either one would have made a decision easier to say, oh, go with this one or go with these two yet.
So that becomes a problem, again, with testing, and particularly testing for which variant people are sick with.
Yep. And how fast could we get those? Even if you can't get it for a patient, can you have a running average of what's happening in your community? So if you suddenly see that only 4% are Omicron and 96% are Delta, you're probably going to err on going with the monoclonal that's for Delta. If you see the reverse, you're going to say, well, it doesn't matter to use those other two. They're going to be ineffective. I'm going to use this one. And we don't even have those kind of data in a timely way, which is part of what I was talking about earlier. We need this national testing prioritization. We need to really put this in there, and that should be part of it for purposes of treatment.
And which monoclonal antibody is most effective for Omicron?
Well, it's one that actually is made in England. It's not very common here. Trovimab is the name of it. Most people wouldn't recognize the name, but it's one that basically it attacks the virus at a different location to the other two, and that still has been shown to be quite effective.
Is that one effective on Delta as well? I mean,
yes, it is.
So, yeah?
It is too, yeah.
Interesting.
Yep.
So that would be like an almost universal monoclonal antibody.
Right now, but tomorrow another variant could show up and it'd be all done.
And that's how it works with this stuff, right?
Yeah, yep.
What was unusual about this in terms of early treatment? This disease is so unique and so different. Like, what do you think could be learned from the way the early treatment of the virus, particularly before the vaccines were administered?
A lot was learned. And, I looked to our colleagues in Italy, to New York, a number of places that the kind of care that they provided, whether it was ventilators, how they approached it, what they did in terms of oxygen, how they helped basically try to regulate what the immune response was or wasn't, and frankly, the survivorship of patients with similar conditions between those early surges in 2020 and even 6 to 10 months later was substantially better. The intensive care community did so much to try to understand what should be the best methods, what should be our standards of care, our best practices. And so we have seen a substantial increase in outcomes for patients just based on that early research.
Do you think that because of our having gone through this pandemic that we are better prepared for another pandemic? Like, say if COVID was to die off, you don't think so?
We're in worse shape.
Why is that?
500,000 healthcare workers have quit their jobs in the last 2 years. I have seen battle-fatigued soldiers who are friends of mine come back from war with less post-traumatic stress syndrome that you see in the healthcare workers. We don't really have a good sense of just how fragile our healthcare system is right now.
If
You
that's
know-
the case, why would they fire so many unvaccinated workers?
Well, they didn't fire so many. There was 1% to 2% at most. 1%. Mayo Clinic.
That's really all it was?
Mayo Clinic fired 700 people out of 700 people out of 77,000. Okay. And again, you have to look at where their jobs were. Were they in intensive care or not? Were they up front? Were they the people that were at admitting, et cetera?
So you think that's a false narrative? That
I
they
think it's
fired
absolutely a false narrative. Absolutely.
unvaccinated healthcare workers?
Very few of the doctors and nurses who work in intensive care were unvaccinated. They wanted to be vaccinated to protect themselves. I mean, we've lost 3,000 healthcare workers have died of COVID since the beginning of the pandemic. And so they want to be vaccinated largely. And as I said, 99% of doctors got vaccinated quickly. I think the challenge is we don't understand yet is how fragile our healthcare system is. So when you ask me, are we better prepared right now? The Department of Labor has just surveyed healthcare workers and think that we're going to see a number of them quitting in the next 3 to 6 months just out of they're burnt out.
What could be done to strengthen and enlarge the healthcare system to make it better prepared for some new pandemic? And what could be done in terms of having treatment protocols prepared in advance?
We have to be better prepared to handle surge capacity. We just weren't.
And is this hospital beds? Is this
no,
staffing?
it's people. It's staffing and training. And the problem is, Joe, that we've lost so many senior doctors and nurses who are just burnt out that even though we have the pipeline coming in from medical school, we've had more applications in medical school in the last year than we've had in many years. But the problem is it takes time to educate them, to get them to be in a more senior status, learned status. And so for this period of time right now, we're going to have real troubles if we have another big surge because it was almost like a vicious cycle. The more people that were infected meant more cases in the hospitals, the more care needed. The more care needed, the more people were stretched. The more people got stretched working, the more quit. The more that quit meant that the fewer people had that much more work to do again and again. And that's
Cascading effect.
And I thought I'd never see this in my lifetime, but all 8 of the major healthcare systems in the state of Minnesota, including the Mayo Clinic, took a full-page ad out in papers around Minnesota back during the Omicron surge, begging people, please don't get infected. We can't take care of you. We don't have the quality of care has dropped. When you were during this recent Omicron surge, you did not want to have a heart attack. You did not want to have an automobile accident or a stroke because of the challenge. We saw people literally waiting 2 days in emergency rooms.
Really?
Oh, it's crazy. And it was just a shortage of staff. So equipment wasn't the problem. Beds weren't the problem. It's people. And so I think that that's one of the things we have to really invest in right now if we're going to be prepared for any future surge. And what we have to understand is how many healthcare workers now, not just the stress of what they did, but how many times that they're vilified in the community because people say, you didn't do what you should have done to save my loved one's life, etc. And they're doing everything they can.
Do you think masks work?
I'll answer that if you can tell me what's similar between a 747 and a car.
What's similar?
Yeah.
They both hold people?
They both have tires. That's it. Well, masks are like tires. They're different. They're totally different. And so whether you had the N95 on, that thing that I wore into the studio, which is a high level of protection, or you wear a face cloth covering, totally difference between night and day how well they work. Shortly when I was on here in 2020, I wrote a piece in April 2020 saying this is aerosol transmitted. It's like a perfume. It's like smoke. And basically you have to have high level respiratory protection to really protect yourself. And what we did is we got into people saying, well, anything works. And some studies were done, which frankly, if one of my graduate students had done those studies, I would have failed them because they were so badly done in terms of trying to understand, did face cloth coverings work? Well, they don't. They're much more of a clothing decoration than they are anything about really working. And so when you ask me, do N95s and KN95s work? I'd say yes. If I say a face cloth covering, surgical mask, no. And that's a big
A
problem.
lot of people are wearing those surgical masks, which are to stop droplets when you're doing surgery, right?
Yeah,
That's what
and not only that, but, just on my trip down here, which this is only my second trip in 2 years. Some of you used to fly 150,000 air miles a year. I can't tell you how many people were not wearing masks at all, even though it was mandated, or they wore them on their chin. They were chin diapers.
Yeah.
That was it. We've been doing a study where we freeze frame news media reports and just look at the people in the frame, whether indoors or outdoors. We have consistently seen since the beginning of the pandemic, a quarter of the people wear it under their nose. That's like fixing 3 of the 5 screen doors in your submarine. It doesn't matter. What good does it do?
So explain to me how N95 masks work if you can breathe out of them.
Yeah.
If you can breathe into it and breathe out of them, what are they doing to protect you from infection? And what are they doing to protect other people from being infected by you?
And that is the key issue right there. People don't understand the difference. There are 2 issues that are critically important to protecting you and protecting others from you. That is fit and filtration. Think about swim goggles. I mean, it's all about fit. If they don't seal completely, they leak, okay? So you got to have something that's a very tight fit. That means also, by the way, you can't wear a beard. If you wear a beard, you invalidate anything you put in front of your face because it all leaks right through, okay? One of the problems we have with kids is we don't have good sizes because N95s, as basically the oversight regulation of those, comes from the occupational world. It's largely for professional use, and we've never really looked at for personal use. So I will have to say fit is a challenge, okay? It absolutely is. But filtration is what's critical, and people don't get this. The material in an N95 is a milk-blowing material. It's actually
It's a what?
A milk blowing. It's like a foam that hardens, okay? And it has...
Are you saying milk?
Milk, yeah. That's what they call it. Yep, just like that, yeah. And it is basically one that has large enough spaces in it that allows air to move through it regularly, okay? But like a good electronic filter you might put in a room, it has an electrostatic charge in it. So as the viruses come through, they get grabbed quickly. And this works really well.
The virus clings to the outside of the mask?
No, actually as it comes in, it's outside, but it's on the inside too. As the mask, that's why it's like it is. And so this special material is what gives you both the breathability, but also the protection. So when you wear a cloth, even if you can breathe, you have no protection. The virus will come right through, in and out.
Oh, okay. So when you see, I'm sure you've probably seen these, there's a doctor who uses a vape pen and he blows through various masks to show you the porous nature of them, and he uses a surgical mask and a cloth mask, but he also uses an N95. So you think that is disingenuous because he's not taking into account the electrical charge of this mask that actually...
Exactly. You want to have it breathable. You want to be able to make certain
you
that...
have to, otherwise you'll die.
That's right. Yeah. I jokingly say I could stop all transmission if you let me put cellophane over people's faces, but that wouldn't last very long. And so that's what makes these so really important. And so what we need, though, is we need a major initiative to basically develop a personal N95-like material that's comfortable, that people can wear with good fit, and that people can actually breathe through in a way that they'll use them.
So the N95 material, and you said it's a milk, what is it?
Milk blown. It's basically
blown?
It's a type of industrial process where they basically put this material down. It has the electrostatic charge in it. It has the porous nature that lets air move in and out.
Now, should they be replaced on a regular basis? And if so, like how regular?
Only when they're really soiled or they're not fitting tight in your face. You can actually wear them for quite some time. I wear my N95 for days.
Days?
Yeah, days.
But you should probably have a new one once a week or something?
If you can, that's great. They run a little over $1.50 some places. And I think the most important thing about them is right now they're readily available. Early on in the pandemic, all of us said don't use them because healthcare workers need them and we had a major short supply. Mm-hmm. But by the summer of 2020, all of the manufacturers had so boosted production that we have more than enough right now. So the public can use them. They can be very helpful, but you got to use them. And, wearing it under your nose or not wearing it. I mean, I find, for example, in schools, The great debate right now is, what we do with masks in schools. So kids go to class all day. They wear their whatever they're supposed to be wearing. Then they go to the lunchroom for half an hour. They take it off while they eat with all their friends. I'm sitting there going, now the virus doesn't take a vacation just when you're in lunch, okay?
So what should they do? Not eat?
No, but I think you have to at that point then figure out, do you need to space people? And just
But does that work?
Well, basically, it's what other option? I mean,
But in an indoor setting,
yeah.
can you really space people out to the point where you can have sick people in the same room and not
Affected. But then that's where ventilation comes in. Ventilation is huge. And what we can do, for example, in fact, you can actually develop and build and put into schools things called Corsi boxes. Corsi boxes, named after the aerobiologist specialists who devised these, are basically taking a regular old fan and putting in a MERV filter, a high-level furnace-like filter on one side of it, and basically attaching it to the fan and then letting the air blow through the filter. Put one of those or two in a room, you can do a great deal to eliminate virus. Things like that we haven't thought about, things that we need to. We should be investing in our ventilation systems in so many buildings, and we're not.
Interesting. So the ventilation systems that they have on airplanes, they've been touted as being very highly effective, right?
They can be more effective. But, I sat next to a guy yesterday in the plane that took his mask off most of the time, and it was a surgical mask to begin with, okay? And so, if you have enough infected people on a plane, I do believe you get transmission on planes. I don't think you can say that they are absolutely perfectly safe. They are safer, clearly by the air filtration, how it goes through the filters that they have and move it around.
But isn't it kind of nonsense if you're sitting right next to a person and they're allowed to take their mask off to eat? Then what is the point of a mask mandate?
Thank you. I agree.
So what should you be doing? You think everybody should be not eating on a plane and just keep
a
N95 tight to your face?
Well, first of all, I wrote a piece, again, not long after I was on here, where I didn't support general lockdowns. I said, you know what? When you have a surge, apply the brakes. And what you're applying the brakes for is trying to keep people from overwhelming the healthcare system. And, of course, you want people not to become seriously ill and die. But that if you maintain lockdowns, as they call them, when you don't have high activity, and we had many parts of Minnesota that didn't know of anybody that got infected in greater Minnesota, and yet they went into that. That's a challenge. But when you do see the transmission, then you want to have that limited time period. Well, I'm the same way with mask mandates. Two things. One, there's a time and a place if you want to try to stop or eliminate transmission as much as you can. But then also don't make a mandate around somebody wearing a face cloth covering.
Because it doesn't work.
It doesn't work.
Or a surgical mask.
Yeah.
And so that is what you see, though, when you have a mask mandate. You see people wearing what you think are very ineffective masks.
And so I continue to come home and say, please wear high-quality respiratory protection. Then I could support more mandates for a limited period of time when you have that surge capacity. What we just went through for the last 10 weeks was an example where if the more we could do to slow down transmission, like that ad in the papers in Minnesota from the healthcare systems were asking people to do, just give us a break. I think that's fair. I think you're going to see a period coming up in the next weeks where, whether the public health thinks you should be wearing a mask or not, the governors have already read the tea leaves and said, no, we're not. And I don't think that's a wrong thing.
When you saw the residual effects of lockdowns, like particularly high suicide rate, depression, drug addiction, there's a lot of businesses went under, a lot of restaurants went under. What do you think could have been done to manage that differently? And do you think that residual effect is just a function of not being prepared and not anticipating anything like this ever happening and not having the steps in place to handle it?
I don't think it's a straightforward issue. What I mean by that is I just saw a recent research effort that just showed that the number one reason for depression during the pandemic was not about losing a job or work. It was losing a loved one. And, when you have 900,000 people die, and it's among the top 10 causes of death for all age groups, when you have 300,000 kids in this country, 300,000 kids who have lost a parent or a guardian who took care of them, that adds to the challenge. So I think that we clearly had an impact by the negative things you just talked about. But how much was actually caused by, quote unquote, these mandates, and how much was caused by just going through a pandemic is hell. It's not, it's tough.
Right. It was both, though, right?
It was both. Though I'm actually acknowledging what I'm saying, though, is trying to understand that isn't itself important for going forward, because we, as I shared earlier in this session, we could see another surge again. So what are we going to do next time? How are we going to be prepared for that? How are we going to communicate to the public? What are we going to tell them we need to do and why? And, right now, I think they tune us out quite a bit because they feel like we don't get it. We're not going to,
Why do you think that is?
One is they're fatigued and tired. I mean, think about Ebola back in 2014-15. It lasted for about 4 months worldwide. It was over with. If you look at the 2009 H1N1 pandemic, it was really about 6.5 to 9 months. And then it was over with. We're now into our third year. Fatigue is setting in. I mean, if I get asked to run a marathon once, that's tough. But if I get asked to do it day after day after day for months and months, I give up. And so I think that part of the challenge we have with this virus, which has made it so difficult, is the long-term nature of what's happening. And I'm not saying that excuses any of the mistakes that have been made about how to approach it, but it's just human nature. Right now, we're challenged. We're tired. We want it done. And so I think that's one thing. I think the second thing, though, is that we didn't communicate clearly what we know and don't know. I started out the program by saying that.
What do you think was done incorrectly by not communicating what we know or don't know?
I think we gave the public expectations that they felt like when things changed quickly, that we were not credible.
Like what, for example?
A year ago, right now, and I'm not taking any great credit, but I made public statements that I thought the darkest days of the pandemic were still ahead of us, and it was because of these variants. I didn't understand how could they affect things, and look what happened. But we had many of the talking heads out there, of which I include myself as a talking head, who were saying to the public, it's over with now. Summer's going to be quiet and calm. The peak has come down. Vaccines flowing. Maybe we'll have a little bit of activity next winter. And then Delta came along.
Why do you think that they made those declarations?
I think there was a situation where we lacked humility in saying what we know and don't know. I mean, when I leave here today, I hope everyone says, Osterholm says, maybe it'll be okay, but maybe it could be another bad one, and we got to be prepared for it. It's that willingness to say, I don't know. I mean, I think probably the three most important words I've said to you all this entire session is, I don't know. And I think that's what we haven't done enough of. And then we have to tell people, so what are we going to do to find out? What do we need to know, to basically answer the question? Well, many of the questions you asked me already. And I think that message is one that we have not done a good job getting out, of just being humble and saying, I don't know, but this is what might happen. This is what could happen.
Speaking of I don't know, was there any more definitive data on Israel, or was it too confusing?
I think that the confusion came with that, because I kept seeing that 4 doses for some people.
The confusion meaning what they determine as to being vaccinated.
Right. What the definition of that word becomes.
So when we walk out of here, my research assistant is going to tell you exactly the answer. Okay.
Why not bring him in here?
Go get him if you want.
We could take a 10-second break.
Yeah,
I guess.
We'll take a 10-second break and go get the data. That'll help everybody.
I like that. Thank you.
Okay, so to wrap it up, what's your assessment of what we just looked at in terms of like the Israeli data?
I think the really important message here, if you look at the countries, what happens to them in terms of cases, severe illnesses, hospitalizations, deaths, it's vaccine, vaccine, vaccine. Good example.
But is it true? Is it 90% of the population of Israel have at least 2 doses of the vaccine?
Yes, the data we have shows that. But the
right,
point of it is
that was what we
no, but
talked
I'm talking
about earlier.
About the fact, if you look at the surge, it's being contributed by those people who are unvaccinated,
completely
or
unvaccinated, or
unvaccinated,
2 shots.
and well, we have a number of them that have 1 shot. which is not nearly enough adequate protection to
Unless
stop
it's
that.
the J&J.
No, that's even people who have gotten mRNA but just got one shot. We still see that here in the United States.
Right,
for
but I'm
whatever
saying,
reason.
is the J&J count as like a one shot? Because one shot is fully vaccinated with the J&J until you get a second one.
I don't know in Israel how much J&J was used. I don't know.
So your thought is the reason why everything's going sideways in Israel is not the failing of the protection of the vaccine, but rather the fact that there is a substantial portion of the population that's unvaccinated?
It's both. But what I'm saying is what really brought that surge on was in terms of hospitalizations, severe illness, and deaths was largely that surge piece was among unvaccinated or one with one dose.
Okay, so it's one dose or zero doses. It's
Yes.
not two doses.
It's not two doses. Right.
So when you hear about vaccinated people catching COVID in Israel, it's a small percentage
Small percentage of what?
of their population that has COVID?
No, actually, I shouldn't say small. Yeah, it is relative. But if you look at the total numbers, we also did see infections among people who were fully vaccinated.
Yes.
What we're talking about, and I talk about that surge, I'm talking about it in terms of severe illness, hospitalizations, and deaths. And that was being driven largely by those who were unvaccinated or who had just a single dose.
Got it.
And that's what those data show.
What
that
is
curve.
going on in Africa, and why did they have such low rates of infection and death?
Well, first of all, we have to be really cautious about saying how many cases they've had
Because there's a
of
lack
how
of testing?
surveillance and testing. And I mean, if you look, for example, at South Africa, where we have better testing, we have better follow-up, you did see increased number of cases. If you look at Zimbabwe, you look at countries like that. And so part of it is that surely it's not the same as the U.S. We're not seeing the hospitalizations the same way, but then we have a much younger age population. Any of those conditions that could predispose. If, your median age is 20 or 30 years younger than it is in a high-income country, right there you have an advantage in terms of likelihood of having severe illness. But I think at the same time, we're trying to study that to understand how many cases did we miss? What are the impacts? And it's been particularly important in Africa for a separate reason, is because public health services have been so disrupted there because of COVID. Levels of vaccination, malaria control, maternal and child health, all these other issues are taking a huge toll right now. And I mean, we're really going to have to reinvest back into that area just because we've lost a lot of footing in our control from a public health standpoint of many infectious diseases.
Is there any other factors that could be a consideration in terms of like the low rates of infection? Do you think that it's just a lack of reporting and testing, or is it possible that there's other medications that they've been taking that could have contributed to their low numbers of infections?
Well, again, I come back and say that it's not just the fact of underreporting. As I pointed out, if you have a much younger age population, you can see big differences in the rate of serious illness, hospitalizations, et cetera, just by that alone. In terms of any of the factors, such as has been suggested, could certain drugs that they may take or how often do they take those drugs could play a role, I'm at this point, again, open to the data. We just have seen so little come out of Africa, and we need more. We need much more information to understand that. I think the South African experience was helpful in allowing us to see what Omicron was going to do. Now, however, we're in a place where even looking at South Africa, that big burst of cases has come down, but it's not going away. There's a tail here that's pretty substantial. Why is that? What's going on in South Africa? So I think the African continent has been largely neglected relative to many other parts of the world to better understanding what COVID has done, both directly and indirectly to the society.
Were there any countries, do you think, that were a model of how to handle the pandemic correctly?
I think trying to make the very best out of a horrible situation, I think Australia and New Zealand have probably done as well as any two countries. And you can say, well, they're islands. But, they pursued this zero COVID policy to the extent that they could. And when it became impossible with Omicron, they graduated their response in a way that I think is really helpful. I mean, just take, for example, New Zealand. Here's a country that with, 5.2 million people. Here's Minnesota, state I'm from, with 5.6, 5.7 million. When you look at our deaths, we've had, 12,000 almost. Look at their deaths. They've had 52 as of 2 weeks ago. What's different? Well, I think in part it's because they did try early on to really have major control and then allow things to be relaxed when the numbers didn't appear to be increasing or the follow-up. And so I think there's lessons here for us to learn across the board. All countries need to go back and look carefully at it. A very interesting piece in the Financial Times a couple of weeks ago, David Byrne Murdoch, who I think is one of the most wonderful journalists today in this topical area, did an analysis looking at what would have happened during the Omicron surge in the United States if, in fact, we had the same immunization rates for COVID as Denmark. And he estimated that about half of all the hospitalizations would have been eliminated. Half. And I think that's probably true. That's why you see lots of cases in Denmark occurring as they've opened up everything, but the number of hospitalizations and people in ICUs have gone down. Because, again, they're actually providing protection against serious illness, hospitalizations, and deaths with their immunization programs. And I think that's a lesson for us going forward. How do we make that work so that we can do more of the same?
Now, what is your take on doctors like the FLCC that had this early treatment protocol for COVID that has been widely disparaged by other people, like the ivermectin, hydroxychloroquine, azithromycin, all that stuff together? Like, what do you think about these doctors that had put out these protocols for early treatment?
Well, I don't have an opinion on the doctors.
Do you have opinion on the protocols?
Well, I'm going to say yes. I think, again, it has to be science-driven, and as I just said earlier in our discussion, I think the data coming out on these 5 trials with ivermectin is going to be very interesting. I am eyes wide open. I'm ready to see them, these double-blind, placebo-controlled trials.
Have you looked at any of the randomized controlled trials that have been done previously?
There were none that were really randomized controlled trials, I can tell you. Looking at the studies carefully, there were so many problems. The one in Brazil was really a challenge. I mean, it again, going back to my previous statement, if one of my graduate students had done that kind of a study, I would have flunked him. So I think we need really much more comprehensive data, and we should be collecting data on these kinds of treatments. So I hope everyone can agree, if you do a double-blind, placebo-controlled trial, that means that neither the patient nor the investigator knows who got the drug and who didn't. Everybody is otherwise the same. They're equal. It's only when the code is broken by the monitoring board does anybody know what the results were. Then we can feel confident that we have a study that is objective, that is based on the data. And, if ivermectin comes out working, you'll hear me say it. If it doesn't, I'll explain what I think the study said and what it meant. So I'm wide open on all of these things. If I had to say anything that I wished we learned from this, is some of these things have to be done much sooner. And agreed, I think a year ago people thought we were done. I wish we had started some of these trials. I wish we had done some randomized controlled trials on masking and how to make it work. What can you do? Maybe you can't. What can you do?
And maybe inform people about what you were saying about N95s.
Exactly, and then share that information as quickly as possible. Tell the story. You understand this, but people really respond to when you tell them a story. I learned a long time ago as a kid growing up in rural Iowa that if I wanted to try to make a point or to try to put forward a position, if I couldn't get it to sell at the 10 o'clock coffee group at the S&D Cafe in my little hometown in Iowa, I needed to go back home and rethink it. How do you get that to sell? And you don't do it by being a salesman. You do it by just being a good storyteller, telling the truth, telling what you know and don't know. And I think that's what we need to do a better job of in public health right now. We need to be that. We need to code it all of it in a dose of humility. Say, what do I know and don't know? I mean, you know what this interview will probably be remembered for? How many times I told you today I don't know.
Well, I think you gave a great analysis of things that went wrong and things that we could have done better. and also the burden on the healthcare providers. I think that's something that people need to be really reminded of.
Thank you.
Okay, your podcast is
The Osterholm Update podcast.
every Thursday.
Every Thursday morning it drops, and it's on our website. It's on Apple. It's on Spotify. It's on all of the services out there, and welcome it. I try. It's again my attempt just to be unvarnished, to be humble, and just to tell you what I know and don't know.
Well, thank you very much for that, and I appreciate you coming back again. And hopefully, we won't have to do this again in 2 years.
Well, if we do, it won't be on this topic.
Yeah, hopefully. Yeah. Well, hopefully, it won't be a new one, right?
Yeah.
All right.
Thank you very much, Joe. Thanks a lot, Joe.
My
Thank
pleasure.
you. Bye-bye.
Thank you. Bye, everybody.
Bye.